Hi everyone, welcome to goclasses. In this lecture, we are going to study SQL Complete Summary. This is going to be the complete summary lecture, the complete lecture of SQL. And let me tell you that every important point, every tricky question, everything I will cover in this lecture. Okay. Also, if you did not study SQL so far, then also you can watch this lecture. And after watching this lecture, we will solve every gate question. Every gate previous year question you will be able to solve based on SQL. You will be able to solve after watching this lecture. Okay. So let's start now. So let's see what is SQL. The full form of SQL, that is structured query language, and this is a database language we already know. Okay, so you can see, you can pronounce this as SQL or you can pronounce as SQL. Okay, so this is a standard query language which is supported by most DBMS software. Most relational DBMS software, they support SQL query language. So you can see this structured query language. This is most commonly used relational database query language. Okay, for RDBMS software, we use this query language most commonly. Okay, so let's see. Let me tell you the first important point about SQL, that is SQL is declarative, not procedural. Okay, so SQL is declarative. What that means and what this procedural means. So let me tell you, SQL is declarative. It simply means, let me tell you what declarative means. Declarative means that, see, when some language is declarative, it means that you just define what to do. You will not define how to do. Okay, if you want to receive some information, you want to retrieve some information, then you will just specify what information you want. You will not specify the step by step procedure to retrieve the information. Okay, so remember, SQL is declarative. Means what it means, it simply means that SQL query specifies what information we want. Okay, so I can say that just only specify we only specify we only specify what we want. Okay, what we want, not how to get it. Okay, not how to get it. Okay, very simple. And what procedural means, procedural simply means that you will define the step by step procedure how to get it. Okay, basically here in the procedural, what we defines step by step procedure, step by step procedure. Okay, about how to get the information. Okay, how to get the task done. So very simple, SQL is declarative, means we will only specify what we want. We will not specify the order in which it will be executed. Okay, we never specify the order in which this query will be executed. We just specify what we want. Okay, so you can easily see, consider this example. You can see this real world example. What is declarative, what is procedural? See this real world example. If you want to make a cup of tea, then declarative language, what it will do, remember, this is our task. Our task is, I want a cup of tea. Okay, then the declarative language, what it will do, it will just simply say what we want. Okay, means get me a cup of tea. But the procedural language, what it will do, it will give the step by step procedure how to get it done. So remember, this is our task. Okay, our task is this. Now to carry out this task, the declarative language will simply specify what we want. Okay, get me a cup of tea. But the procedural language will define step by step process. Okay, how to get the task done, give me the step by step procedure. So you can see, go to kitchen. Okay, get sugar, milk, tea, mix them, heat over the fire. Okay, till it boils, then put it in the cup and bring it to me. Okay, is this clear? Please tell me this analogy, is this clear? Procedural versus declarative. So remember, SQL is a declarative. Okay, in SQL, when you write SQL query, then you are basically specifying what you want. You are not specifying how this will be executed. Okay, how this information will be basically how this will be implemented, how this will be executed, okay, how the SQL compiler or the DBMS software, how that will carry out the task, that you will not specify. You will just specify what you want. Okay, so you can see SQL is declarative, not procedural. Declarative programming is where you just say what you want without having to say how to do it. Okay, you can see. So declarative programming means here you just mention what you want, okay, what you want, without having to say how to do it. Okay, similarly with procedural programming, you will specify the steps to get the result. Okay, step by step procedure to get the result. And remember, SQL is declarative, so the queries don't specify the steps to produce the result. Okay, in the SQL queries, we don't specify the steps to produce the result. We just specify the information we want. What we want, we just specify that. Okay, so I hope you understood. Okay, very simple. Now let's move on. So you can see SQL is declarative, not procedural. Now, one thing I want to tell you, that this point we will revisit after some time. We will revisit this point. SQL is declarative. What it actually means, we will revisit this point after some time. So remember this point. Okay, we are going to revisit this point. Now let's see the next topic, that is set versus multiset. Multiset is also called bag. Okay, these two, they are same. Either you can call it multiset or you can call it bag. Now, what are the difference between set and multiset? So you can see set. You already know set. What are set? Set is unordered collection of items which do not have duplicates. Unordered distinct collection of items. Okay, set is unordered collection of items which are distinct, means there are no duplicates. And what is a multiset? Multiset means bag. Both are same. So what is a bag? Bag is unordered collection of items, but duplicates are allowed, may contain duplicate. Okay, so remember the difference between set and bag. Bag means multiset. This is another name, bag, or you can call it multiset. So remember, set is unordered. The order doesn't matter. Unordered collection of items where no duplicates. Yes or no? Where we have no duplicates. Okay, so unordered, no duplicates. In bag, this is also unordered. The order doesn't matter. This is also unordered, but remember, here duplicates allowed. Here duplicates are allowed. Okay, is this clear? So very simple point. For example, if I give you, consider this structure 1 comma 2 comma 2. Okay, so here you can see, remember, if this is a set, then this is same as 1 comma 2. If this is a set, okay, if this is a set, so okay, let me clarify this. Remember, when I say that you have a set, you have a set 1 comma 2 comma 2, then this is same as 1 comma 2. The duplicates you will remove. Yes or no? The duplicates are removed. No duplicates. Okay, so the duplicates you will ignore. So remember, if I say this is a set, it means there are no duplicates. Okay, so this is same as this, and I can say this is same as this. But remember, when I have multiset or when I have a bag, if I say that this is a bag 1 2 2, then remember this is not same as 1 comma 2. Is this clear? Okay, remember, here you can see that this item 2 we have 2 times, but here this item 2 we have 1 time. So remember, in a bag, you can see duplicates are allowed, so duplicates matter. Okay, so remember, this bag and this bag, they are different. It's like this. In this bag we have these same chocolate 2 times, same chocolate 2 times. Here this chocolate we have 1 time, so they are different. Agree with me? Yes or no? Okay, you can consider this real life bag. There is a real life bag, so you can see that unordered, order doesn't matter, but duplicates are allowed. So can I say every set is bag? Can I say every set is a bag? Yes, every set is a bag, because remember, duplicates are allowed. It is not necessary that you have duplicates. It is not necessary. Every set is a bag. But can I say every bag is a set? Can I say every bag is a set? Every bag is not a set. Okay, so you can see, for example, if I give you this 1 2 2, then remember, this is a bag. This is not a set. Okay, this is a bag, this is not a set, because in a set we don't have duplicates. We remove the duplicates. In a set we remove the duplicates. So remember, if I say this is a set, if I say this is a set, then it simply means you will remove the duplicates, so this will be same as this. Okay, so very simple point. So remember, this is a bag, but this is not a set. I hope this point is clear. So every set is multi-set, but converse is not true. Okay, is this clear? Now let me tell you some more points. For example, consider some bags. I am giving you some bags. Okay, for example, you look at this bag. Can I say this is same as this? Are these two bags same? Yes, they are same because they are unordered. Bags are also unordered. Okay, but remember this 1 comma 112, that is different from 122. That is different from 1 comma 2. Okay, is this clear? That is different from 1 comma 1 comma 2. Okay, is this clear? So very simple point. I hope all these points are clear. Now remember, for example, 1 comma 1 comma 1. Here this item 1 we have 3 times. This item 2 we have 1 time. This item 3 we have 4 times. Okay, so this is another bag. So in a bag, can I say that frequency of items matter? Yes or no? This is another bag. And can I say that frequency of items matter? Yes. Here you can see the frequency of 1, that is 3. Okay, this 1 is appearing 3 times. This 2 is appearing 1 time. This 3 is appearing 4 times. Okay, so very simple. In a bag, frequency of elements matter. Okay, this is what I can write. That in a bag, the frequency of elements matter. Frequency of elements matter. Okay, so very simple point. So you can see, tell me, is this a bag or is this a set? Look at this table. Is this table a bag or is this a set? You can see this tuple is repeating. Okay, you can easily see. So this is a bag. This is a bag of tuples. This is a bag of tuples. This is not a set of tuples. Okay, remember here we have how many tuples? There are total 4 tuples. Okay, remember there are total 4 tuples here. Okay, for example, look at this bag. In this bag we have total 3 items. Okay, in this bag we have 3 items. Okay, is this clear? Very simple point. Okay, for example, look at this bag. In this bag, how many items we have? 4, 5, and 8. So total 8 items we have. Very simple. So here you can see this is a bag of tuples because this tuple you can see this is repeating. Okay, so can I say this is a bag of tuple? Yes. Okay, this is not a set of tuples. I can say this is not a set of tuples. Okay, very simple. Now, let me tell you one very important point about SQL. About this SQL query language, let me tell you very important point, that is this SQL treats table as a bag, not as a set. In SQL, our table, our relation is a bag. Okay, so duplicate rows are allowed. Is this clear? This is very important point because remember, if you study relational algebra, then there our table, our relation does not have duplicate tuples. But in SQL, our relation can have duplicate tuples. Our input relation can also have duplicate tuples. Our output also can have duplicate tuples. So remember, in SQL, the input, output, basically everything is a bag of tuples. So duplicate tuples are allowed. I hope this point is clear. So remember, SQL allows same tuple to appear more than once in a relation. Okay, so in SQL, remember your table, your relation is a bag of tuples. It is not a set of tuples, it is bag of tuples. So duplicate rows are allowed. I hope this point is clear. Okay, so you can see that in the relational algebra, our input, our table, that is a set of tuples. Yes or no? There are no duplicates. So you can see in a set, we have no duplicates. Okay, for example, your relational algebra that uses set semantics. So when you solve any question of relational algebra, then your table has no duplicates. Okay, now remember, our SQL uses bag semantics. What it means? It means that duplicates are allowed, duplicate tuples are allowed, and number of duplicates is also significant. The frequency also matters. Okay, very simple point. So I hope all these points are clear. Now let me tell you the difference between relational algebra and SQL. What are the differences between these two? Okay, because there are many misconceptions here. So let me tell you about the difference between these two, SQL and relational algebra, so that when you are solving any question of relational algebra and when you are solving any question of SQL, then you can take care. Okay, all these small points you can take care. So let me tell you the first important point. What is that? The first important point is relational algebra uses set semantics. It means that in relational algebra, our table is a set of tuples. Okay, but SQL uses bag semantics. So remember, relational algebra treats the table relation as a set of tuples, so no duplication of tuples. But SQL treats the table as a bag of tuples, so duplication of tuples is allowed. This is very important point. Okay, is this clear? Let me create the diagram. So remember, when you have a relational algebra query, so this diagram will help you. So if you have relational algebra, in this relational algebra, remember our input and output, that is set of tuples. Okay, that is set of tuples, our input and output. But remember, in SQL, our input and output, they are bag of tuples. So you can have duplicate rows. Okay, is this point clear? Okay, so very simple point. I hope this point is clear. Bag means multiset. Another name for bag is multiset. Okay. Now let me tell you the second important point. That is, there are no null values in the relational algebra. If you remember, when we studied relational algebra, at that point I told you that there are no null values in the relational algebra. Okay. So when you are solving relational algebra question, will you ever consider null values in your input table? In your table, will you consider null values? No. So remember, there are no null values in the relational algebra, but SQL table can have null values. Okay, so null values concept is not there in the relational algebra. Now you might be thinking, sir, in relational algebra we have outer joins, full outer join, left outer join. Yes or no? We have outer joins, and in the outer join, when the output of the outer join, that has null values. Yes or no? You might be thinking. See, I am saying that there are no null values in the relational algebra, but you might be thinking, sir, outer joins have null values. So let me tell you, outer joins are not considered part of classical relational algebra. You can consider that outer joins, they are basically, they were added as a extended features of relational algebra. So remember, outer joins, they are extended features of relational algebra. They are not considered part of classical basic algebra, basic relational algebra. Okay, so this is very important point I'm telling you, that whenever you see any question of relational algebra, then you never have to worry about null values. Never. Don't worry about null values. There are no null values in the relational algebra. But SQL may have null values. In the SQL table, you can have null values. You can see this screenshot, you can see from this university. Okay, you can see there are actually no concept of null in the relational algebra. Okay, so this is a university screenshot. You can see there are actually no concept of null in the relational algebra. In the relational algebra, we don't have concept of null values. Now let me tell you the third point. That is the third difference between SQL and relational algebra. So in the relational algebra, can I say that your table must have at least one primary key? Can I say in the relational algebra? Can I say your table, your relation must have at least one primary key? Yes. There will be actually exactly one primary key. In the relational algebra, your relation, your table will have exactly one primary key. There will be at least one candidate key. Yes or no? All these points you already know. But remember, in SQL, you may not have a primary key, you may not have a candidate key. Okay. So you can easily see, for example, in SQL, this type of table is allowed. Okay, SQL table. Okay, consider this table R. In SQL, this type of table is allowed. A, B. Okay. For example, 1, 2. I told you duplicate tuples are allowed. Okay. Yes or no? Now you tell me here. You look at this and tell me, is there any primary key here? Is there any primary key in this table? Okay, you can see if there is primary key, then you cannot have duplicate tuples. So there is no primary key here. Yes or no? In this, there is no primary key. Okay, is this clear? So very simple. Okay, because if you have primary key, then you cannot have duplicate tuples. There is no primary key. There is no candidate key here. There is no. Okay, so very simple. Now you can easily see that in general, SQL table is not required to have a key. Okay, SQL table may not have a primary key, may not have a candidate key, but relational algebra must have exactly one primary key and at least one candidate key. You can see that relational algebra must have primary key and candidate keys. Okay, you can have at least one candidate key. So you can see this is the screenshot from Navate book. This is the book Navate. Okay, you can see this. In general, SQL table is not required to have a key. Although in most cases there will be key, but in general, SQL table is not required to have a key. Okay, is this clear? An SQL table, but now you tell me one thing. If I tell you that SQL table has a key, now can you have duplicate tuples? If I give you this information that SQL table, I give you this information that you have SQL table, and in this SQL table, this is a key, this is primary key. Now can you have duplicate tuples? Now you cannot have duplicate tuples. So remember, if I give you this information in the question, if this information is given that your table has a key, has a primary key, then you cannot have duplicate tuples. So remember, an SQL table with a key is restricted to being a set. Okay, since the key value must be distinct in each tuple. Very simple point. Okay, so these are the points. These are small points. I hope all these points are clear. Please tell me all these points, are they clear? Let me know. Anyone has any doubt in these points? So let me give you the summary. What is the difference between relational algebra and relational and SQL? And these are important points. So when you are solving relational algebra questions, then what you should keep in your mind, and when you are solving SQL question, what you should keep in your mind. Okay, so what is the first point? Tell me the difference between relational algebra and SQL. Relational algebra works purely on relational model. Remember, this works on pure relational model. Works on pure relational model. Yes or no? Because in the relational model, we don't have duplicate tuples. We have exactly one primary key in any table. We have at least one candidate key. Yes or no? So relational algebra works on pure relational model. This SQL, this is based on relational model, but not exactly. Okay, yes or no? Is this clear? So remember, SQL is based on, okay, this is based on relational model. This is based on relational model, but not, but not, I can say, but not exactly. Is this clear? This is loosely, I can say loosely based on relational model. Okay, I can also say that this is loosely based on relational model. So this is based on relational model, but not exactly. And this works on pure relational model. Okay, this is the first difference. What is the second difference? The second difference is in the relational algebra, there are no duplicate tuples. There are no duplicate tuples. Okay, or I can say you have set of tuples, but here you have bag of tuples. Here our relation is bag of tuples. Okay, what is the third? The third is there are no null values in the relational algebra. We don't have any null values. We don't have the concept of null values. But here null values might be there. Null values allowed. Null values actually matter. They are actually important. In SQL, null values are actually very important. Okay. Now, what was the fourth point? Must be a key. Yes or no? Key is mandatory. Primary key, candidate key. Okay, these things are mandatory. But in this, okay, key may not be there. Okay, I hope all these differences you understood. Is this clear? Please tell me. Very simple. One more point about null values. See, relational algebra has no null values and SQL has null values. Why? Because actually null values, these are practical features. See, relational algebra is theoretical language. This is a formal query language. This is a theoretical query language. This is purely based on theory. But this is practical query language. This is commercial query language. Yes or no? This is real world query language and this is theoretical query language. So in SQL, null values matter. In SQL, null values, they are very important. But in relational algebra, we don't have null values. Okay? Is this clear? So remember, when you are solving any question of relational algebra, then don't consider null values because as I told you, there is no concept of null values. You can see there is no concept of null in the relational algebra. You can see this screenshot from this top university. Okay. Now let's move on. Now let's see SQL basic query. How the basic SQL query looks like. Okay, so you can see this is your basic SQL query. So we have these keywords in SQL. We have select from where. Okay, select, here we will write the attributes. From here we will write the name of the tables, and where here we put the condition. Okay, so let me tell you that this is a basic SQL query. The basic SQL query is this. The basic SQL query has these keywords. Okay, there is select keyword. This is a keyword, select keyword. There is from keyword and there is where keyword. Okay, so these are the keywords. Select from where. Okay, in this from, here we write the table names. Okay, basically, for example, R1, table R1, table R2, table R3. These are the table names. Okay, in the select, here we write the attribute names, which attribute we want to project. Okay, for example, attribute A1, attribute A2, attribute A3, A4. Okay, so these are the attributes we want to project. And in the where, we write the condition. We write the condition for tuple selection. Okay, so let me tell you one thing. This is how the basic SQL query will look like. And now few more things. Actually, in SQL, this select, this keyword is used for projection of attributes. Okay, so let me tell you that this select, this is used for projection of attributes. Okay, is this clear? Projection of attributes, basically which attributes finally we want in the output, which attributes we want. So this select keyword is used for projection of attributes. Okay, do you remember in the relational algebra, this select, this was used for selection of tuples, yes or no? But remember, in the SQL query, this select keyword is used for projection of attributes, means which attributes you want in the output. Okay, this where. Okay, why this where is used? This is used for tuple selection. Okay, this is used for tuple selection. Okay, based on this condition, the tuples which will satisfy this condition, they will be in the output. So this is for tuple selection. Okay, very simple. And this from, this is used for cross product, means these tables we have to use, means you just consider the cross product of these tables. Okay, so from, this is basically your cross product, I can say. Okay, so this from, this is like your cross product that you consider these tables. Okay, is this clear? Very simple. So this is the idea. This is basic SQL query. This is how it will look like. Okay, so from these tables we are taking these attributes, and this is the condition, remember, for tuple selection. The tuples which will satisfy this condition, only they will be in the output, and only these attributes will be in the output. So this is how the basic SQL query will look like. Now let me also tell you the conceptual evaluation of basic SQL query. So this is your SQL query. You have, okay, this is your SQL query. Okay, you have select. Let's assume you are selecting these attributes a comma b. These attributes you are selecting from. Let's assume you are selecting from r comma s. Okay, maybe t. From these tables you are selecting where some condition is there. Okay, some condition, tuple selection condition. Okay, some condition, some condition is there, some condition c is there. Okay, is this clear? For example, some condition, let's assume that condition is like this, that where c is greater than 5. Okay, this condition is there. Is this clear? So where you have c greater than 5. So let me write it, where c greater than 5. Now let me tell you the conceptual evaluation. When you see this query, then what actually this will output. So let me tell you the conceptual evaluation. Conceptual meaning, conceptual evaluation of this query. Okay, of basic SQL query. So the conceptual evaluation is like this. Okay, that first you do the cross product of these tables. Okay, this is the conceptual evaluation, that first you do the cross product of these tables. So r cross s cross t means every tuple of r with every tuple of s with every tuple of t. Yes or no? The combination of all the tuples. Very simple. So first you consider this cross product. So this is your first thing. First you will consider the cross product. Then you will apply this condition. Okay, on this cross product, remember r comma r cross s cross t. On this cross product, remember you will apply this condition. Okay, it is like this, that in the SQL, in the relational algebra we use this, yes or no, for selection of tuples. So basically you will apply this condition. I can say on this table you will apply this condition. This condition you will apply c greater than 0. This condition you are going to apply on this table. Okay, only those tuples where you have c greater than 0. So I can say that r comma r cross s cross t. In this, you just select those tuples where you have c greater than 0, c greater than 5. Okay, c greater than 5. This is the condition. Now, what is the third thing? The third thing is you will project these attributes. Okay, you will project attributes a comma b only. Okay. Now you tell me one more thing. SQL treats the table as a bag. Yes or no? Duplicate tuples are allowed. So you tell me one thing. In the input table, can you have duplicate tuples? In the input table, in the r comma s comma t, in these tables, can you have duplicate tuples? Yes, you can have duplicate tuples. Tell me, the output, can it have duplicate tuples? The output, can it have duplicate tuples? Yes, it can have duplicate tuples. Okay, I told you that SQL query, the input is duplicate, the input is bag of tuples, the output is bag of tuples. So this is the conceptual evaluation of basic SQL query. First you will do cross product of these tables, then you will apply the tuple selection condition, and then you will project the attributes a comma b. Let's see example. Consider this table. So this is your, you can see, product table. The name of this table, that is product. So this is your product table. Now you consider this query. Look at this query. This is select these attributes. So remember, in the final output, we will have these attributes from the product table. This is your product table where this is the condition. Okay, this is the tuple selection condition where category is equal to gadgets. Means this category, this should be equal to gadgets. Only these tuples will come in the output. Okay, so finally output will be what? Very simple. Remember, first you will apply this. Yes or no? The conceptual evaluation, what is that? The conceptual evaluation is first you will do this. Okay, from this product table. From this table, we are going to apply this query on this product table. Next, then the second step is this condition. Yes or no? You will select the tuples. Okay, so you can see we will select the tuples where category is equal to gadgets. So you can see where category is equal to gadgets. So these tuples are gone. Okay, this tuple is gone, this tuple is gone. So finally, these two tuples will be remaining. And remember, we are projecting these attributes. We are projecting this P name, price, and manufacturer. So finally, your output will be this. Okay, for this query, this is the final output. Is this clear? Please tell me. This is the final output. Is this understood? Let me know. Very simple. Now let's see. Now consider this query. In this query, what this star means? What this star means? This star actually means that we are taking all the attributes. Okay, so remember, let me tell you this point, that if we want to project all attributes, if we want to project all attributes, project all attributes. If we want to project all attributes, then what we can do? We can use select star. Then use select. In the select clause, in the select clause, you just put star. Okay, is this clear? From rs, and where you have condition, where there is some condition, there is some tuple selection condition. Okay, so very simple point, that use this star will simply means all attributes. Okay, very simple. So here also you can see that again the same thing. From product table, this is your product table. Okay, so let me write it. This is the product table, and from this table you will select these tuples where category equal to gadgets. Okay, so remember, you will select these tuples. So these two tuples will be gone. These tuples will be gone. And finally, you are projecting all the attributes. So this will be your output. We are projecting all the attributes. Very simple. Now let's see this. Find all 18-year-old students. Okay. So now let's write the query. Write the query to find all 18-year-old students. So tell me how you will write. Let me know. What will be the query? Very simple. From, so this is your students table. Remember, the name of this table is students table. So this is the students table. So from this students table, we want where age equal to 18. Yes or no? And we want all the attributes. So it will be select star from students where age equal to 18. Yes or no? So this will be the answer. So you can see from students where age equal to 18, select star. Now one more thing I want to tell you here. Okay, actually for this query you will write for this query you can write the SQL query. Yes or no? Now let me tell you that you can see this concept students as what this means. Tell me, from students as what this means. Actually this is also correct. For example, I can just simply remove this and I can simply do this. This is also correct query. This is a correct query. Okay, from this is your students table. Okay, where age equal to 18, select star. Okay, give all the attributes. Now you can easily see students as what this actually means. This simply means that this is like that this table we can refer with this name as. Okay, so let me tell you what this as simply means. It simply means this is called alias. Okay, this is called alias, or you can call it renaming. Basically renaming, it is basically renaming. Okay, alias, or you can call it range variable. Okay, or you can call it range variable. These are formal names. This is range variable, or you can call it tuple variable, or you can call it rename. Okay, all these things are same, or you can call it renaming. So very simple that basically we are renaming this student table as s. So we can refer to this table by this tuple variable. Okay, you can call it range variable or you can call it tuple variable. All these are different names for the same thing. You can call it alias, you can call it renaming, you can call it range variable, or you can call it tuple variable. It simply means what? It simply means that this table we can refer by this name as. Okay, very simple. So you can see from students as, that basically this is your table as dot age equal to 18. Okay, select star. Very simple. So this is very intuitive. Now let's move on. Tell me the answer for this question. Find number of tuples in the output of both queries. Two queries are given to you. This is relational algebra query, this is SQL query. Find number of tuples in the output of both the queries. So what that will be? First let me tell you about, first let's see this query. This is relational algebra query. Now remember, in the relational algebra, okay, forget about this query for now. In the relational algebra, this is our relational algebra query, right? Okay, yes or no? This is relational algebra query. So in the relational algebra query, we never have duplicate tuples in the input, in the output, yes or no? Relational algebra treats the table as a set of tuples. We don't have duplicate tuples. So when you have relational algebra query, see, simply you can remove the duplicate tuples. Do we have duplicate tuples? If there is duplicate tuple, you can remove it. If there is duplicate tuple, we don't have duplicate tuple. Okay, but if there is duplicate tuple, you can remove it, because in the relational algebra our input, output, basically everything is set of tuples. Okay, now let's see. From this member table, this is the member table, we are projecting. This pi means projection. Okay, projection of attributes. So finally we are projecting gid. So your output will be what? Your output will be gid. Okay, so this will be your output, gid. There will be dps. Okay, there will be gov, there will be abc. You will only have duplicate tuples. Okay, you will only have distinct tuples. You will never have duplicate tuples in the relational algebra query. Your output will always have distinct tuples. Okay, you will have set of tuples. Very simple. So that's it. Yes or no? That's it. So your answer will be, for this query, the answer will, output will have 3 tuples. Simple. Now you tell me about the next query. About this query, select gid from member. From this table, from this member table, we are projecting gid. Okay, so duplicates will be removed or not? Duplicates will not be removed. Yes or no? Okay, because SQL will have the table as a bag of tuples. SQL treats the table as a bag of tuples. So duplicates are allowed, duplicate tuples are allowed. So here you can see the output. The output will be gid. Output will have, remember, will have all these 6 tuples. Okay, so in the output, basically you will have like this: dps, gov, abc, gov, ABC, GOV. Okay, so I can say that output will have 6 tuples. Simple. Okay, so you can see this is the answer. So the answer for this query has 3 tuples. This query will have 3 tuples. This query will have 6 tuples. Okay, let's move on now. Now, if you want distinct tuples, then can you do something? If I only want distinct tuples, I don't want duplicates, I want distinct tuples, then SQL gives you a facility. SQL gives you this keyword distinct. What you can do? You can use select distinct. Okay, you can use this select distinct. Now, if you use this select distinct, then all the duplicate tuples will be removed from the final output. From the final output, all the duplicate tuples will be removed. So remember, if you want distinct tuples, then use the keyword distinct in the select clause, meaning that only distinct tuples should remain in the result. Is this clear? Very simple. So in the select clause, just use this keyword distinct. Simple, very simple. Then all the duplicate tuples from the final output will be removed. Okay, you can see now in this same table, if I use distinct keyword, okay, for example, if I do select distinct, if I use this select distinct, okay, select distinct GID, select distinct GID from member table, right? From member table. Okay, now you tell me, now what will be the final output? The output of this query, if I run this query, select distinct, okay, remember select distinct, what it will do? Select distinct, it will remove all the duplicate tuples from the final output. From the last output, all the duplicate tuples will be removed. Okay, so from this table, from member, we are projecting GID. Okay, we will project GID, but we will not have duplicate tuples. We will only have distinct tuples. Okay, so we will have DPS, GOV, ABC. Okay, that's it. So we will have only 3 tuples. Okay, the output will have only 3 tuples. It will give you 3 tuples only. So this is the feature that is given by SQL. Okay. Now let me tell you one thing, that in the SQL, tell me, can I say where clause? Can I say that is mandatory? In every SQL query, is it mandatory that you have where clause? For example, look at this query. See this query. Do we have where clause? Okay, in this SQL query, from this table, we are projecting this attribute. So in this SQL query, do we have do we have where clause? We don't have where clause, right? So let me tell you this note, that in SQL, select and from, they are mandatory in all SQL queries. This is important point, that in the in the SQL query, these two, select comma from, they are mandatory. Without select comma from, you cannot write SQL query. Okay, but where clause is optional. Now, for example, look at this query. Find name and login for all students. Okay, this is your student table. Then what we are doing here? Do we need where clause? Do we need to filter the tuples? Tell me. Do we need the where clause? We don't need where clause. We just want name and login for all the students. Name, login. We just want to project these two attributes. Yes or no? These two attributes we want to project. So very simple. This is your answer. That from, this is your student table. Okay, so from students S, again I am telling you, this S, this is your tuple variable, or I can say this is your alias. Okay, alias, that this is your student table. You can refer this table with the name S. Okay, this is your alias, that this is your student table. We can refer this table by this alias S. Okay, so you can see select as.name as.login. Very simple. Now, one more important point, that is SQL is case insensitive. Okay, tell me, in SQL, when you write select, when you write this select something something, then is it mandatory you should write it in capitals? No, remember, you can write select, you can write, for example, you can write like this, there is no problem. You can write like this, SELECT. Okay, all these are fine. Is this clear? So SQL is case insensitive. So keywords, okay, remember, keywords you can write in uppercase, lowercase, doesn't matter. Okay, for example, your from, you can write like this also, you can write like this also, that is fine, that is fine. Okay, you can write like this also, so everything is fine. Another thing, the table name, so these are for keywords, yes or no? These examples I have given for keywords, that keywords are case insensitive. But remember, the table names are also insensitive. For example, the table name students, okay, you can write it students also. Is this clear? You can write it stu, like this also you can write. Is this clear? Okay. Similarly, the attribute name, okay, for example, if I write as name or maybe age, okay, the attribute name, for example, age, you can write like this also, you can write like this also, you can write like this also. Okay, I hope all these points are clear, that SQL is case insensitive. Okay, so whether you have, for example, table name, okay, you can see this is your table name, this is the example for table, and this is the example for attribute. Okay, understood? Now, where is the exception? Do we have exception? Okay, SQL is case insensitive. So remember, the uppercase, lowercase, these things don't matter. So where is the exception? The exception is only with the strings. So remember, SQL is case insensitive, but okay, strings, but string name is case sensitive. Okay, the string name that is case sensitive, and it is written in the single quote. Okay, for example, if I have a table, let's assume this is the table R, and in this table, let's assume you have S name. Okay, S name. Now let's assume that S name, that is Ram. Okay, let's assume. So you can see, and so on. Now, here, let me tell you that if I want to write, for example, if I want those tuples where S name is Ram, okay, let's assume here you have, for example, okay, Raju. Okay, here you have Ram. Okay, and so on. So now if I want those tuples where you have this S name equal to Ram, then what I will do? Very simple. From from this table R, okay, where I want where S name. This S name is attribute. So tell me, does case matters? Uppercase, lowercase, does it matter? S name is attribute. So here it doesn't matter, right? Okay, so S name. S name is equal to, but here this is a string, right? Yes or no? Here this is a string. So remember, we write it in the single quote. Okay, string is written in the single quote. So you will write Ram like this. Okay, is this clear? Please tell me. And you will select star. Okay, so very simple. I hope this point is clear. So remember, string is written in single quote, and remember, string is case sensitive. What this means? What this means? See, string is case sensitive. What that means? That means like this. If I have this, and if I write this, then how many tuples will be there in the output? Tell me. See, here you have capital RAM. Here you have small. Okay, if I write like this, then tell me how many tuples will be there in the output. So the output will have only one tuple. Okay, is this clear? So very simple. SQL is case insensitive. The only exception is string. String is case sensitive. Okay, and it is written in the single quote. Very simple. This is a simple point. I hope you understood this. So for example, look at this example. See, this is a string, right? I want those tuples where category is equal to gadgets, where this attribute category, this is equal to gadgets. So what I will do, you can see this is the attribute name, this is the attribute name, but this is a string. So string is written in the single quote, and you can see gadgets. So that is the reason you can see your output will be this. I hope this point is clear. Okay, you can see case insensitivity. You can read this. Remember, SQL is case insensitive. Okay, all these things you can read. So basically, uppercase, lowercase letter, these things don't matter. Okay, whether you have keyword or whether you have attribute names, relation names, alias, names of attributes, names of relations, alias. Okay, all these are case insensitive, as I told you. The only exception, is that inside the single quote. Yes or no? This is the only exception. String. inside the single quote, that is case sensitive. Okay, so you can see. Now let's move on. So that's it. We have seen the basic query. This is our basic query. Select from where? From these tables. Based on this condition, you select the tuples. Okay, this is the condition for tuple selection, and you project these attributes. Okay, this basic query, this is called SFW. SFW. Yes or no? So this is also called SFW query, or you can call it SPJ. Select project join. What is project here? In this entire query, which attribute is used for projection? In this query, which attribute is used for projection? For projection, this attribute is actually used. Okay, select attribute, this keyword. This keyword is actually used. This keyword is used for project. Then tell me which which keyword is used for select. See, this keyword is used for projection of attributes. Then which keyword is used for select? Select means selection of tuples. Okay, so for that we use where keyword. Where keyword for selection of tuples. Simple. Okay, and this join, this is your from. Yes or no? This join, this is a from keyword, because we are doing the cross product. So this is from keyword. We use from keyword for join. Simple. Okay. Now, so you can easily see that this query, this SQL query, this corresponds to, but not exactly equivalent. Okay. So this corresponds to, basically first you will do the cross product, then you will do the tuple selection, and then you will project these attributes. So this, remember, this SQL query, this is similar to this relational algebra query. Yes or no? This SQL query, this is similar to this relational algebra query. But can I say they are exactly equivalent? Can I say they are equivalent? Let me know. What is the difference? They are not equivalent. This query, they are not equivalent. They will give you different, they can give you, they may or may not give you different result. So tell me, where is the difference? The difference is, here we don't have duplicates, but here we have duplicates. Here we can have duplicates. Yes or no? So in the SQL, duplicate tuples might be there, but here we don't have duplicates. So remember, that is the reason, but not really equivalent to. They are actually not equivalent because of duplicate tuples. In the relational algebra, we don't have duplicate tuples. Okay, so we have seen the basic SQL query. This keyword you can use distinct if you want distinct tuples. Okay, the conceptual evaluation we have already seen. First you will do the cross product of from, okay, from this from list. So first you will do the cross product, then you will select the tuples, then you will project the attributes, and then you will apply the distinct keyword, and you will eliminate the duplicate rows. So this is the conceptual evaluation. Simple. Okay, let's see this query. Tell me how many tuples will be there in the final output. Let me know. So these tables are given to us, and this is the SQL query. How many tuples will be there in the final output? So here you can see this is your students table. Remember, this is the students table, and this is the enrolled table. Okay. Now what this query is doing? See, what is the conceptual evaluation? Tell me, what is the first step of conceptual evaluation? How you will evaluate? How you will understand this query? What is the first step? The first step is cross product of from clause. Yes or no? You will do cross product of these two tables, S comma E. Okay, this will be your cross product. So you can see step one, that is cross product. You do the cross product of all tables from the from clause. Okay, very simple. So this is the cross product. Yes or no? This is the first step. Very simple. So first step is done. Now what is the second step? The second step is, after doing this cross product, you will apply this tuple selection condition. Yes or no? You will select tuples. So this tuples will be selected. So you can see step two. Step two is a tuple selection. Make sure that where clause is true. Okay, so this tuple selection. What is the tuple selection? You can see s.sid equal to e.sid and e.grade equal to b. So you can see e.grade must be equal to b. Yes or no? And there is and e.sid, s.sid, they must be same. So only this tuple will be selected. Yes or no? Only this tuple will be selected. All the remaining tuples will be eliminated. Okay, very simple. So finally, this is your second step. Now the third step is you project these two attributes, as name and ECID. Okay, so the output will be John's history 105. Yes or no? So the third step, step number 3, that is you will project the columns. Okay, so remember as name, ECID. So this will be your final output. So your final output will have only one tuple. Yes or no? In the final output, there will be only one tuple. Very simple. Now let's move on. Now let's solve this question. Tell me, these tables are given to you. This is the sellers table, this is the bots table, and this is the reserves table. Now, this is the query. In the output, how many tuples will be there? Let me know. Tell me one thing. Will you do the cross product? Will you do the cross product? Let me know. Will you do the cross product? No, of course not. Yes or no? There is no need to do the cross product. Okay. See, first step, conceptual evaluation, first step, that is cross product of sellers, comma reserves. So only these two tables you have to consider. Only these two tables. Okay. So you will do the cross product. Actually, in the cross product, how many tuples will be there? In the cross product. Cross product means every tuple combined with every tuple. Okay, so total 6 tuples will be there in the cross product. Yes or no? Now, remember after the cross product, you will select the tuples. Yes or no? You will do the tuple selection. So the tuple selection condition is given to you, that is BID must be 103. So after doing the cross product, you will select the tuples where BID equal to 103. So if BID equal to 103, then which tuple will be gone? See, you can simply remove this tuple. Sorry, you can simply remove this tuple because BID must be 103. So you can just simply remove this tuple. And you can see this is the condition. Seller SID, reserve SID, they must be same. Okay, so you can see this row, this will match with which row? See, this will match with actually. Okay, you can see because this tuple is already gone, so this will not match with anyone. So only this will be, this will happen. So in the final output, only one tuple will be there, and you want as name. So your final output, okay, the final output will be as name, that is Bob. That's it. Yes or no? Only one tuple in the output. Is this clear? Let me know. Very simple point. Remember, in the conceptual evaluation, the first step is you do the cross product, but you don't have to do the cross product in the gate exam. Okay, you don't have to do the cross product. You can logically understand. Okay, just understand logically that these two tables we are considering. Okay, so just look at these two tables. Forget about this table. Yes or no? I don't care about this table. This bots table, I don't care. So only look at these two tables. Now this is the tuple selection condition, that seller SID equal to reserve SID and BID must be 103. See, in the cross product, you want those tuples where BID equal to 103. So this tuple you can simply remove. Okay, yes or no? This you can remove. So very simple. Only this tuple will be remaining, BID equal to 103. And then you will also see that seller SID equal to reserve SID. So you can see that only this will match. This 95, this 95, 95, and 103. That's it. So only this tuple will be there in the output. And finally, you are projecting as name. So this will be your final output. Only one tuple in the output. You can see. Okay, this will be your final output, Bob. Now let's move on. Now tell me the answer for this question. Write a SQL query to output table R as it is. We want to write SQL query to output table R as it is. Basically, we want to read table R. We want to read table R. So tell me, can I give you this in the options? Let's assume option A is given to you. Option A is R. Is this correct? Option A, that is R. Is that correct or not? Option B is from R. Is this correct? Option C is select star from R. So which is correct? Let me know. Remember, in the SQL query, select comma from, they are mandatory. I told you that in any SQL query, these two keywords, they are mandatory. They must be there in every SQL query. So this is actually correct. This is not correct. This is not correct. In every SQL query, select comma from. These keywords are mandatory, I told you. So remember, very simple, select star from R. Okay, tell me one more thing. If I give you this option, is this correct? Select distinct star from R. Is this correct? No, this is also not correct. Yes or no? This is also not correct because your table R, it can have duplicate tuples. So we want to read table R. So we want duplicate tuples. Yes or no? Okay, but this will remove the duplicate tuples. So we want to read table R. So this is the answer. Answer will be option C. Now let's move on. So you can see if you want to read table R, reading table R, then how to do? Very simple. Select star from user. You are reading the table user. Very simple. And this star, this means all columns. We are projecting all the columns. I told you where clause is optional, but select comma from, they are mandatory. Okay. Now let's move on. Now consider this query and tell me in the output how many tuples will be there. Tell me quickly. This query on your screen, these tables are given to you. You can see this is the students table and this is the enrolled table. So tell me in the output how many tuples will be there. So what you will do, tell me, very simple. From students comma enrolled, these two tables you have to consider where where there is and here. Okay, there is and here. Basically, in the cross product, we want those tuples. This is tuple selection condition. We want those tuples where E grade equal to B. Okay, where E dot grade equal to B. So you can see, you can just remove these tuples. Yes or no? We want E dot grade equal to B. This E dot grade, this must be equal to B. So you can simply remove these tuples. Okay, only these two tuples will be remaining. Now, SID and E dot SID, they must be same. So you can see this will match with whom? 5366. Okay, so you can see this actually, this will match with this. They will match. Yes or no? And this will not match with anyone. So finally, you will only have one tuple. Okay, that's it. So remember, your final output will be this. This is the final result you can see on your screen. Okay, the final result will be, you can see we are projecting s.name e.cid. So your final output will be John's history 105. This is your output. Okay. So we have seen all these things. Now, SQL, one important point. Do you remember I told you that SQL is declarative? And I told you we will revisit that point. Okay. So this is a small point. This is a small detour. So an important point. SQL, how we understand SQL and how they actually happen. See, how you understand query and how actually the query is executed, they are actually different. Okay. So do you remember I told you SQL is declarative? Declarative means we will define, we will specify what we want. We will not specify the step by step procedure to get the result. Yes or no? I told you SQL is declarative means we don't specify step by step procedure to get the result. Yes or no? We just specify what we want. We don't give the order of execution. We don't specify the order of execution. So you can see we are saying SQL is declarative, not procedural, but we are also providing evaluation order. Yes or no? Isn't it contradictory? See what I'm saying. On one side, you are saying SQL is declarative. Okay, this is side one. You are saying that SQL is declarative. Declarative means we specify what we want. We don't specify how to get the result. We don't specify the order of evaluation. Okay, on one side, you are saying SQL is declarative. On another side, you are giving the SQL evaluation order. You are also giving the SQL evaluation order. Do you remember the SQL evaluation order? What was that? The SQL evaluation order, first you do the from clause, then you do the where clause, then you do the select clause. Yes or no? This evaluation order also you are giving. So tell me, there is a contradiction. Do you agree with me? On one hand, you are saying that SQL is declarative. On other hand, you are giving the execution evaluation order that first you do this, then you do this, then you do this. So tell me, is this contradiction or not? Let me know. So where is the mistake? Either this is wrong, either this is wrong. One of them is wrong. So tell me which is wrong. Let me know. I hope you understood my question. Yes or no? Because remember, SQL is declarative, means we just specify what we want. We do not specify the step-by-step order of execution. Okay, in which order to execute, we don't specify that. But you can see we are giving this order of execution. So either this is wrong or this is wrong. One of them is wrong. Which is wrong? Let me know. So the answer is actually this is just a conceptual order of evaluation for our understanding. This is not how DBMS will do. DBMS will not do like this. Yes or no? The DBMS software, it will not do like this. So remember, this is actually correct. SQL is declarative. This is actually correct. And remember, this is not a evaluation order. Please understand. This is a not evaluation order. This is just a conceptual evaluation order. This is just a conceptual evaluation for human understanding, for our understanding of query. Okay, is this clear? So remember, this is just a conceptual evaluation, nothing else. The DBMS will not do like this. DBMS is not dumb. Yes or no? For example, just think about it. If you give this query, let's assume there is a table R. In this table R, let's assume you have these attributes, and there are, let's assume, 1,000 tuples. Okay, in this R there are 1,000 tuples. Just think about it. And there is table S. In this table S, let's assume you have C comma D, and here let's assume you have another 1,000 tuples. Okay, or maybe 10,000 tuples. Now consider this query. This very simple query. We want from R comma S, from these tables, we want all attributes. Select star. Okay, where this B is equal to 5. Okay, this B is equal to 5. B is equal to 5, and let's assume D is greater than 6. Okay, consider this query. Now, see, very simple. Now you can easily see that this is your query. Now you tell me one thing. Let's assume that in this table there are 5 tuples with B equal to 5. Okay, only 5 tuples with B equal to 5. And in this table, only 2 tuples with D greater than 6. Yes or no? Are you getting my point? Let's assume 2 tuples with D greater than 6. Okay, see, very simple. 2 tuples in S with D greater than 6. And let's assume 2 tuples or maybe 3 tuples in R with B equal to 5. Okay, now you tell me, okay, just think about it and tell me, is DBMS dumb? That DBMS first it will do the cross product. Just think about it. That DBMS is very dumb DBMS, right? Yes or no? It will be a very dumb DBMS if it does like this. Okay, dumb DBMS will do like this. That first it will do the cross product. If you do the cross product, how many tuples will be there in the output? 1,000 multiplied by 1,000, 10,000 multiplied by 1,000. Yes or no? That is 10 to the power 7. Yes or no? That is 10 to the power 7 tuples. Okay. Yes or no? Is this clear? Next. What is next? Next, it will do the where clause. Okay. Yes or no? Now, next, it will do B equal to 5 and D greater than 6. And then it will do the projection. Project all attributes. So, okay, just think about it. Will DBMS do like this? DBMS will never do like this. Will never do like this. Okay, so again, I'm telling you, this order of evaluation, this is just a conceptual order of evaluation for human understanding, for our understanding. DBMS will not do like this. Remember, SQL is a declarative language. So in the SQL query, we are just specifying what we want, what result, what information we want, but we do not specify the order of execution. Okay, and So tell me, who will decide the order of execution? Order of execution will be decided by the DBMS. DBMS will decide. We don't know. We do not know how the DBMS will execute. There will be a lot of parallelism. Let me tell you. Okay. Actually, let me tell you internally what will happen. The DBMS software, first it will pass the query. Okay. See, when you give this query to the DBMS, when you run this query, then first the DBMS will check whether this is valid or not. Then what the DBMS will do? It will convert this SQL query to relational algebra query. Okay, this SQL query will be converted to relational algebra query. Then relational algebra query will be efficiently optimized. Okay, so remember this SQL query will be converted. So let me tell you, internally something like this will happen. This SQL query, okay, this will be converted to relational algebra query. Equivalent relational algebra query. Then that will be optimized. Okay, that will be optimized. Another query, another relational algebra query you will get. Okay, then there will be a lot of parallelism. Okay, parallelly a lot of things will happen. Okay, so like this. So very simple point. Anyway, we don't have to go into this. This is not in the syllabus that how the execution will happen. Okay, so how the execution will happen, that depends on the DBMS. DBMS internally it will execute. Okay, it is possible that first DBMS will do this, then DBMS will never do the cross product. DBMS will simply do this. So remember, a lot of things are there. Internally, DBMS can do a lot of things. Okay, so that's it. So this is what I'm saying, that SQL is declarative, SQL is not procedural. So this evaluation order that we study, that first you do from, then you do where, then you do select. This evaluation order that we study, this is not actual evaluation order. This is not how DBMS will do. Okay, so let me tell you this, that this is not how DBMS will do. DBMS will not do like this. DBMS will not execute like this. So if you study any standard book, then you will see this word conceptual evaluation. Now, is this clear what this conceptual evaluation means? And this is a misconception I have seen. Many students, they have this misconception that, okay, this is how the execution will happen. But think about it. If this is how the execution will happen, then why are you calling SQL declarative? Okay, there is some contradiction. Yes or no? Very simple point. So remember, this is just a conceptual evaluation. If you study any standard book, they will use this word conceptual evaluation. But actual evaluation, that is very much different. DBMS will not execute in this order. Okay, this is how we understand. We understand the query like this. Okay, so you can see the evaluation of SQL query that we study, that is conceptual evaluation, not how DBMS will do. Okay, not how the query will be evaluated by DBMS. DBMS will evaluate the query in very efficient way, in a different way, in a very efficient way. Okay, you can see this screenshot from the Raghurama Krishna book. You can see conceptual evaluation strategy. Okay, this simply means how to evaluate the query for easy to understanding purpose rather than efficient. Yes or no? We understand the query by this conceptual evaluation, but DBMS will execute in a different way. DBMS will execute the query in a very efficient way, in a very different way. Okay, so you can easily see. There will be a lot of query optimization, but that is not in the syllabus, so we will not go into that. Okay, one simple point I wanted to tell you, I have told you. Okay, now this homework question I want to give. Will you try this? Let me know. So this is the homework question. This query is given to you. These two tables are given to you. Number of tuples in the output. So this is your homework question 1. Please write your answer in the comments. This is your homework number 2. So please write your answer in the comments. Okay, try to solve these questions and write your answer in the comments. For this homework number 2, the answer is available in the next slide. Okay, I will not show you, but answer is available on the next slide. So try to solve this question and put your answer in the comment. Now let's see SQL writing and understanding SQL queries. So let me tell you some simple steps to write and understand SQL query. If in the GATE exam SQL query will be given to you, how to understand that? So these are the steps. Look at the given database. Okay, first you look at the given database and you decide which tables you need for the information. You want some information, for that information, which tables you need. Okay, so first to decide that. That is your step number 1. First to decide which tables you need for your required information, for your desired information. The step number 2, that is Draw the table side by side and think about the idea. Do the mapping. Okay, and finally implement the idea. So let me tell you, actually, most of the time what will happen. See, for example, if I give you a query, like let's assume this query is given to you from this table RST. Okay, and where this condition is there. Okay, some condition is there, right? And some attributes you want. So when you have this query, then let me tell you what you will do. First, you think about the idea. Before writing the query, before understanding the query, first you understand the idea. First, you write them side by side, because anyway, you are doing the cross product. Okay, so first you write them side by side. This is R, this is S, this is table T. Then you decide what condition is given to you. For example, this type of condition might be given that, okay, this attribute value should be equal to this attribute value. Yes or no? This attribute value should be equal to this attribute value. Maybe this attribute value should be greater than this attribute value. And in the final output, maybe the question is saying that, okay, final, this will be in the output. This is projected. This is projected in output. So very simple. So just think about the idea. What is the idea? Okay, is this clear? Write the table side by side and think about the idea. Now let's see some examples. Find the names and ages of all the sellers. These are the database. This is your database. In the database, there are 3 tables. Okay, seller, bots, reserves. In the seller table, you can see this underline. What this means, tell me. This underline, what this means? SID. This is underline. This means this is a primary key. So your seller table, can it have duplicate tuples? Let me know. Your seller table, can it have duplicate tuples? No, it cannot have duplicate tuples because there is primary key. We are saying that SID is a primary key, so you cannot have duplicate tuple. So you can see this is your database. These are the tables. Okay. So now you tell me, if I want this information, names and ages of all sellers, then how many tables I need? Let me know. First, to decide which tables you need. This is what you decide first. Which tables you need. So you need only one table. Yes or no? I want and ages, names and ages of all sellers. So only this table is required. Okay, very simple. Sellers. So very simple. From the sellers table, from the sellers, okay, this sellers, I can give this alias as. Yes or no? This alias as I can give. From the seller, I will just project. Yes or no? Select as dot name and ages. Yes or no? So select as dot as name, comma, as dot age. Simple, that's it. So this is your query. Is this clear? This is your query. So you can see, if I run this query on this table, then how many tuples I will get in the output? Okay, this is your query. Select. I want attributes. Which attributes I want? I want as name. I want age. These attributes I want from the sellers table. Okay, so tell me, if I run this query on this table, then how many tuples will be there in the output? So duplicates will be removed or not? Let me know. Duplicates will be removed or not? Duplicates will not be removed. Okay, so you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 tuples will be there in the output. All the tuples, basically, all the tuples will be in the output. So I can say output will have 10 tuples. 10 tuples in output. Okay, and only these 2 attributes will be in the output. As name, comma, age. Only these 2 attributes. And is there any duplicate tuple? In the output, do we have duplicate tuple in the output? Yes, there will be duplicate tuple. You can see Horatio 35, Horatio 35. Yes or no? This duplicate tuple also will be there. So that's it. So you can see, if you use distinct keyword, then how many tuples will be there in the output? So you can see, without distinct, 10 tuples. Okay, without distinct. Remember, without distinct, this Horatio 35, duplicate tuples will be there without distinct. But if you use distinct with distinct, what will happen? With distinct, this duplicate tuple will be removed. So you will have 9 tuples. You can see only one time, Horatio 35, one time. Let's see this query. Find all sellers with rating above 7. How many tables we need? First you decide. Remember, step number one is look at the database and you decide which tables you need for your desired information. I want sellers. I want all sellers with rating above 7. So rating I can get here in the seller table. So only one table, only seller table we need. Okay, so your query will be this. You can see from the seller table where rating is greater than 7. Remember, we want rating greater than 7. So where rating is greater than 7, only those tuples we want. Okay, and we can use select star. Yes or no? We can simply use select star. So either you can do this or you can simply use star, select star. Okay, so this is same as basically select star. Simple. Okay, so this is the query. Now let's see this. Find the names of sellers who have reserved bot number 103. How many tables you need for this information? Step number one, look at the database and you decide which tables you need for this desired information. Find the names of seller who have reserved bot number 103. Okay, I want names of seller. Which table will give me names of seller? I want names of seller. Which table give me names of seller? There is only one table which can give me names of seller, that is seller table. Yes or no? Sellers table. Next, reserved bot number 103. For this information, we need reserves table. So only two tables we need, seller comma reserves table. Now you think about the idea. Step number one is over. Now step number two, what is that? That is the idea. You write them side by side. See, sellers, this is your sellers table and this is your reserves table. Okay, what we want, let me know what we want. See, in the reserves table, you can see SID BID day. This is the primary key. The primary key is SID BID day. That is the primary key. So in the reserves table, you have SID, you have BID, and there is day. And in the sellers table, you have SID, S name, and there are other things. Okay. In the output, what you want? You want this in output. Okay. So just think about the idea. You want this in output. And so can I say names of seller who have reserved bot number 103? So can I say this SID and this SID must be same? For example, here you have SID 102. Okay. And the name is, let's assume, Raju. Now you can see this SID. It is possible this can book many bots. Yes or no? Okay, it is possible that 102 can have, for example, maybe this bot number 101, 102, 103. Okay, all these bots. Yes or no? So very simple point. What we want that SID must be same. Okay, so this SID, I can say this SID and this SID, they must be same. They must be equal. So only these conditions you, and remember BID must be 103. BID must be 103. Then this S name we want. Yes or no? Is this clear? Please tell me. We want S name. We want those sellers name who have reserved bot number 103. So very simple. So you can see we will check that SID must be same. That this 102, okay, which bots this 102 has booked? This seller, which bots this seller has booked? Maybe different bots this seller has booked. Okay. In the reserves table, can I say SID is the primary key? In the reserves table, can you have duplication of SID? In the reserve table, can you have duplication of SID? Yes, we can have duplication of SID because in the reserve table, SID BID day, this is the primary key. This combination is the primary key. Okay, all these three attributes combined, that is the primary key. Okay, so you can easily see that for this SID, we will see that bot ID must be 103 and the name, this name we will put in the output. So finally, your query will be this, that okay, from sellers, okay, this alias we can use reserves from these two tables. Okay, where, which type of tuples we want those tuples. Remember, ultimately we want those tuples where s.sid must be same as r.sid and r.bid must be equal to 103. Then we will select s.sname. So this is the query. Okay, is this clear? So this is the query. Now, so you can see very simple. On your screen, you can see this query. If you don't want to use alias, then can you do? If you don't want to use alias, then also you can do. Without alias also you can write from sellers comma reserves, seller.sid equal to reserve.sid and bid equal to 103. Okay. And you project s name. So like this. Let's move on. Tell me the answer for this question. Find seller SID who have reserved at least one bot. I want seller SID who have reserved at least one bot. How many tables we need for this query? First, you tell me how many tables we need. I want seller SID who have reserved at least one bot. See, for this information, only one table is enough. This table is enough. Only this table, that is enough, because in this table, see, in this table we have SID. We want SID, we have SID. And in this table, every SID has booked at least one bot, yes or no? Because this is the reserve table. So in this table, every person in this table has reserved at least one bot. Okay, so finally what I can do, from reserves table, very simple. I will simply just select SID, that's it. Just select SID. This is your query. Select SID from reserves. That's it. This is your SQL query. Very simple. Now let's move on. Now let's see this. Find seller's name who have booked at least one bot. Now which tables we need? Now we need a seller's name. This seller's name, who can provide? Seller's name can be provided by only seller's table. Yes or no? And at least one bot, who have reserved at least one bot. For this information, we need these two tables. Okay, these two tables we need. Very simple. And what condition we have to put? See, this is your sellers table and this is your reserves table. Okay, so what condition which type of tuples we are looking for? See, we are looking for this type of tuple. See, notice, we are looking for this type of tuple. There is s name. This we will put in the output. In the output, we will put s name. So we are looking for this type of tuple where this SID and this SID, they must be same, right? Yes or no? If you have 102, you have 102. So they must be same. That's it. And this s name we will put in the output. There is no other condition. We don't have any other condition. Okay. Yes or no? So you can see 102, 102. That's it. This is what we have to check, that 102, 102. Because remember, because in this reserve table, every SID has booked at least one bot. Okay, very simple. So your final query that you already know, that from these two tables, okay, from sellers table, let's call it S, from reserves table, let's call it R. Okay, these are the alias. Now, what you need, where there is only one condition you have to put, that is that s.sid is equal to r.sid. Okay, and you will select what you will select. You will select s name. That's it. This is your query. Is this clear? You will project s name. Now tell me the answer for this. Find the names of sellers who have reserved a red bot. So tell me how many tables we need. Names of seller, who can give you sellers table? Yes or no? Color, who can give color? Bots table. Okay, who will give you the color? See, the color is given by the bots table. Yes or no? Look, color is given by the bots table. You can easily see. So bots table. So you need bots table, you need seller table, and reserves. So you need reserve table. Okay, so all these tables you need. Now, what is the idea? You just think about the idea. Okay, everything else you can easily do. See, just think about the idea, which type of tuples you are looking for. You need sellers, reserves, okay, and bots. Okay, all of them you need. Yes or no? So tell me which type of tuples you are looking for. This is what I want to ask you. Okay, what type of tuples are you looking for? So let me know. For example, in the sellers, you have SID and there is S name. Only these are important. In the reserves, you have SID, you have BID. In the bots, you have BID, you have color. Okay, so tell me which type of tuple are you looking for? So we want names of those sellers who have reserved a red bot. Okay, so remember, we want this in the output. We want this in the output where this seller, for example, this seller 102, this seller 102, remember this seller 102 must reserve a bot. Okay, this bot, for example, okay, maybe bot number 2, and this bot number 2 has red color. Yes or no? This bot number 2, this should have red color. Is this clear? This is the idea. So remember, these two things must be same. Very simple. These two things, they must be same. These two things, they must be same. And this must be red. And the output will be S name. This type of tuple you are looking for. Yes or no? At least one this type of tuple must be there. Do you agree? This type of at least one tuple must be there. This type of tuple what you are looking for. Very simple. So you can write the query. Okay. So the query will be from sellers, reserves, bots. From these three. Okay. The condition will be what? The tuple selection condition. That will be where seller SID equal to reserve SID and reserve BID equal to bot BID and bot color equal to red. Okay. Project as name. Project as name. So you can see this will be your query. Names of seller who have reserved at least one bot. So these three tables you need, and this will be the condition. Seller SID equal to reserve SID and reserve BID equal to bot BID and bot color must be red. And then you project as name. So this is the query. Very simple. Let's move on now. Tell me the answer for this query. Output of the following query. Let me know. So this is the query. You can see from bots comma reserves from these two tables. Bot ID equal to uh, reserves dot bot ID and bot color equal to red, and we are doing r dot sid. So tell me, what is the output? Seller who have reserved all the red bots or at least one red bot? Let me know. Can I say we are getting sellers who have reserved all red bots? No, the answer will be at least one red bot. Okay, this will be the final answer. Yes or no? Sellers who have reserved at least one red bot. Okay, because what will happen? See, in this query, what will happen? First, you will do the cross product. Every tuple of reserves with every tuple of bots. Yes or no? Every tuple of this table with every tuple of this table. Okay, then finally this condition you will apply. And do you remember that this condition is applied on every tuple? Yes or no? See, this condition will be checked for every tuple individually. Okay, yes or no? This condition checked. So remember, this condition is checked for every tuple individually, independently. Okay, very simple. So finally answer will be sellers who have reserved at least one bot. What is the answer for this question? What is the output of the following query? This query is given to you. This is the database that you already know. Okay, we will use this database, these tables, seller, bot, reserve. Okay, so this is the query on your screen. Now you tell me the answer. What this query is giving you. From sellers comma sellers, you are using sellers table two times. Sellers X, sellers Y. Okay, alias, you can see sellers alias X, sellers alias Y. So this seller table you are using two times, where X age is greater than Y age, and you are projecting X name X age. So what the answer? Name and age of youngest seller, oldest seller, name and age of sellers who are not youngest, who are not oldest. What is the answer? Let me know. Let me know. So for this question, the answer will be option C, not option B. The answer will be option C. Think about the idea. Think about the idea. Okay, just see, when you have this query, then always write the idea. This is the answer. Okay, let me tell you. What is the idea? Tell me. On your screen, this query is there. You just think about the idea. Do you want to lose 2 marks in the GATE exam because you don't want to take your copy pen? You don't want to use your copy pen, so you will lose 2 marks in the GATE exam. Take your copy pen. Take your copy pen. See, option B is saying oldest sellers, and option C is saying not youngest. Okay. For example, first let me clear this point. For example, okay, just think about it. Let's assume you have these sellers SID, S name, age. Okay, so let's assume there is a seller, SID 10, 11, 12, 13. Let's assume here the age is 20, here age is 21, here age is 22, here age is 30. So who is youngest and who is not youngest, who is oldest? So can I say this is oldest? These simple things I have to tell you. Okay, this is not good. Okay, this is young, this is youngest, and these are not youngest. Yes or no? Is this clear? Oldest people can be multiple. For example, this also can be oldest. There can be multiple oldest people, although all of them are oldest. Yes or no? These are oldest. But you can see all these are not youngest. So I hope this point is clear. Simple. Okay, now you look at this query and think about the idea. So tell me, side by side, I will write the tables. How many tables I need? Side by side, I will write the tables. Sellers table, alias X. Seller table, alias Y. Two tables I will write side by side. Very simple. Okay. Now here you have SID, here you have S name, and here you have age. These things you have. Similarly, here you have SID, you have S name, you have age. Okay, yes or no? So here the cross product will happen, that you already know. Okay, the cross product will happen. Correct? In the conceptual evaluation, the cross product will happen. After the cross product, yeah, I can say every tuple of this with every tuple of this. Yes or no? You will have every tuple of this combined with every tuple of this. Okay, finally, what you want? You want this type of tuple. You are interested. You are interested in this type of tuple where X age means this age, this value must be greater than this value. Okay, is this clear? So this type of tuple I am interested where this value must be greater than this value. Greater than. Okay, and remember, I want this S name in the output. This will be in the output, and SID age in the output. Okay, so these two things in the output. Yes or no? So that's it. Now you tell me. So ultimately, which I can say what we are getting in the output. Now just see. If I give you the seller table, okay, let's consider this table. Seller, I'm giving you SID, S name, age. Okay, some tuples I'm giving you. Okay, for example, I'm giving you that 10, 11, 12, 13, 14. Okay, S name can be anything. It anyway doesn't matter. Okay, this can be anything. Let me just quickly write it. A, B, A, C, B. Okay, let me write it like this. Now the age, let's assume that age is 20, 20, 21, 30, 30. Okay, let's assume these are the ages. Is this clear? Okay, so now you tell me in the previous query, what is happening? There will be two copies of the seller table, seller X, seller Y. Yes or no? Correct? Okay, so finally in the query, what is happening? That there will be two copies of the seller table. You will do seller X cross product with seller Y, cross product with seller Y. This is what you are going to do. Okay, yes or no? Seller X cross product with seller Y. So every tuple, remember, in this, tell me how many will be there. In this, how many will be there in the cross product? Tell me, in the cross product, this is your cross product. So in the cross product, how many tuples will be there? Let me know. In this cross product. So you can see 5 into 5, there will be 25 tuples. Yes or no? Remember, every tuple combined with every tuple. This tuple will be combined with every tuple. Okay, this tuple will be combined with every tuple. This tuple will be combined with every tuple. So every tuple combined with every tuple. So in this cross product, there will be 25 tuples. Okay, is this clear? Now, out of these tuples, which type of tuple are we looking for? For example, okay, just tell me. Remember, we are looking for this type of tuple where x dot age is greater than, this should be greater than y dot age. Okay, x dot age must be greater than y dot age. So because of this, Okay, tell me, for this seller, will we get this type of tuple? For this seller, are we going to get this type of tuple where x dot age is greater than y dot age? See, this tuple will combine with every tuple, right? This tuple, it will combine with every tuple, but you can never get, for this seller, you can never get x age greater than y age. Yes or no? Okay. For example, whatever you do, you combine this with anyone. Okay, this tuple you combine with anyone, you will see that you will never get x age greater than y age. This type of tuple you will never get for this seller. For this seller also you will not get this type of tuple. Okay, but for this seller, what will happen? See, for this seller, what will happen? You can see the age is 21, and this will combine with everyone. So this 21, this will combine with this also. Yes or no? Okay. Finally, you can see. Similarly, you can see. Look at this 13. Okay. This also, this 30. This tuple will combine with everyone. Okay. So it's like 20. Similarly, for this 30. Okay, 21. So anyway, the point is that because of at least one tuple, we are getting these people in the output. Do you agree? Because of at least one tuple. Okay, so that's it. Finally, in the output, these people will go. Okay, these people, remember, these people will go in output. Okay, in the output, we will have these people. Okay, these people we will have in the output. Is this clear? Let me know. So finally, I hope you understood the answer. So remember, for this query on your screen, for this query, actually output will be what? See, the output is name and ages, name and age of those sellers, name and age of those sellers who are older than at least one person. Yes or no? Can I say who are older? Who, because of this condition? Okay, who are older than at least one person, who are older than at least one person, means who are not youngest. Is this clear? Please tell me. Let me know, did you understand? So finally, the answer will be option C. I hope this point is clear. Simple, right? Okay. So remember, who are older than at least one person, who are older than at least one person, at least one person. So it means they are not youngest. So the answer will be option C. Now let's move on. Okay. This query you can easily write. Find the colors of bots reserved by Luber. How many tables you need? If you want to write query for this, then tell me how many tables you need. We want colors of bots. For that, we need this bots table. Okay, we want Luber. Luber means we want S name. S name equal to Luber. And reserved. So we need these. So these three tables we need. Yes or no? All these three tables we need. So what is the idea? The idea is very simple, that the name, seller name must be Luber. Yes or no? The idea is this. Remember, this type of tuple we are looking for. I am looking for this type of tuple where S name is Luber. Okay, and this Luber must reserve at least one bot of at I want colors of bots. Okay, there is a bot table in which we have colors. So remember, this color will be in the output. Yes or no? I will put colors in the output because I want colors of bots which are reserved by Luber. So this Luber, okay, the SID, there will be some SID. Yes or no? Now this Luber must reserve. Okay, this Luber means this SID must reserve a bot. Okay, yes or no? Whichever bot. Okay, whatever bot you have. For example, let's assume your bot 30. Here also 30. Okay, and finally this color we want. Okay, this color we want in the output. So remember, these are the conditions you have to put. That name must be Luber. This is the first condition. This is the first condition. The second condition is this must be same as this. They must be equal. Okay. And the third condition, is that BID, they must be equal. Okay. So three conditions are there. And in the output, we will put colors. Okay. Is this clear? So very simple. So finally, your output will be this. You can see that S name must be looper and R dot BID equal to B dot BID and S dot SID equal to R dot SID, and you will project the color. So that's it. So these are the SQL queries. I hope you understood. Is this clear? Let me know. Did you understand so far? Everything that we have seen so far, did you understand? Now let's see SQL keywords. Some more keywords we will see, that is union, intersect, except. These are the keywords. Okay. And these are also very important. So let me tell you that we have in the SQL, these are the keywords. SQL provides some keywords. Okay. And what are those? This is a keyword union. Another keyword is intersect. This is the keyword. Intersection is not a keyword. Okay. Intersect is the keyword. So remember, these are the keywords. Okay. Keywords. These are the keywords. So you can see union is a keyword, intersect is a keyword, and except is a keyword. Also, let me tell you this except. Some people use minus, not some people, actually Oracle database, used by Oracle database. Oracle DBMS uses this keyword minus, but this is more standard. Standard SQL keyword. Okay. So very simple. So remember, these are the keywords. This minus is also a keyword which is used by Oracle database. Okay. And other you can see except. Now, these are the keywords. And what is the purpose? What is the purpose of them? The purpose is very simple, that this is used for union. Let me tell you, these union, intersect, and except. Okay. These are actually same as your relational algebra, means they are actually set union. Let me tell you, the purpose is set union. Please understand, the purpose is set union, means duplicates will be removed. This keyword will remove the duplicates. Okay. Is this clear? Intersect, this will do the set intersection. Basically, these keywords will treat the table, the input, as a set of tuples. These keywords, they will treat the input table as a set of tuples, and they will produce set of tuples. There will be no duplicate tuples. Is this clear? So that is the reason, again I am telling you, that the purpose is set union, set intersection, and set difference. Okay. I hope you understood. Is this clear? So very simple. So remember, these keywords, they will remove the duplicates. They will treat the table as if it doesn't have duplicates. Okay. So they are like, I can say, set operations. They will use the set semantics. Okay. I can say that they will use set semantics. This is what I can use. Set semantics they will use. Is this clear? Actually, what these keywords will do, let me tell you. So first of all, these are the tables. These are the keywords. One more thing I want to tell you, that if you want to apply these keywords, the query format will be like this. Query format using these keywords like union, intersect. Okay. How the query will look like? What is the query format? Except. Okay. So tell me one thing. Can I write, like, for example, R union S? Okay. Can I write like this? R union S. Can I write like this? No, that is invalid. Okay. Why? What is the reason? Tell me why. What is the reason? The reason is simple, that because in the SQL query you must have select comma from. Okay. You cannot do like this. Actually, the query format will be what? Okay. Let me tell you the query format. The query format using union comma intersect comma except, the query format will be like this, that there will be a query here. Okay. You will write some subquery. Basically, there will be a subquery here, subquery Q1. There will be subquery Q2. Okay. And you will use here these keywords. For example, you can use this keyword intersect. Okay. This is the format. Is this clear? Please tell me the format is clear. This is your entire query. This is your query. This is the query. Okay, so in the query there will be subquery q1 intersect subquery q2. Or one more thing, if you want to apply union intersect except, then these two must produce the result which is union compatible. Do you remember there is something called union compatible? Means, remember, I can easily say this is a note, okay, to use these keywords like union intersect, okay, to use union intersect except. If you want to use them, then what should happen? This should happen that the output of this subquery and the output of this subquery, they must be union compatible. Yes or no? Result of subquery q1 and q2 must be union compatible. Must be compatible, union compatible. And what that means? When we say union compatible, what that actually means? Union compatible, this means, okay, two tables. When can I say two tables are union compatible? So let me write on the next. Okay, what is the definition of union compatible? Okay, see, if you have R, okay, let's assume these are the attributes A, B, C, and if you have S, let's assume these are the attributes D, E, F. Then union compatible means the number of attributes must be same. Okay, also the domains must be same. Means, okay, union compatible, R comma S are union compatible, are union compatible. These are the conditions. The first condition, number of attributes must be same. 3 attributes, so 3 attributes. Okay, is this clear? Number of attributes in R comma S must be same. Okay, and the second point, what is that? Remember, in this order, the domain must be same. For example, the domain of A comma D must be same. The domain of A must be same as domain of D. The names can be different, no problem. The names can be different, but domain must be same. Domain of A must be same as domain of D. Domain of B must be same as domain of E. And domain of C must be same as domain of F. Okay, so this is the union compatibility definition. Is this clear? So very simple thing. The query format using these keywords, union, intersect, except, this is the query format. Okay, there will be subquery q1, there will be subquery q2, and here you will have this keyword intersect or union or except. So remember, this will be the query format. And also, let me tell you the result of this query and the result of this subquery. The result of these two subquery must be union compatible. Okay, you can see, to use these keywords, the result of subquery q1, q2 must be union compatible. Okay, very simple. All these points are very simple. So if you want to use these, then you can apply them on any two tables which are union compatible. Means, number of attributes must be same and the columns should have same domain in the order. The columns taken in the order must have same domain. Okay, so very simple point. I hope this point is clear. Now let's move on. So that's it. Now, one more thing I want to tell you. I told you that union, intersect, and accept, they treat your table input also output as set of tuples. Is this clear? So remember, they will ignore the duplicates in the input. Is this clear? So you can easily see that here you can see the set semantic. The union, accept, intersect, what they will do? They will remove the duplicates from the input table and they will remove the duplicates from the output table. Is this clear? So you can see duplicates are removed, are eliminated from the input, and duplicates are removed from the output. Okay, or you can say that they will ignore the duplicates from the input table. In the input table, all the duplicates they will ignore. They will assume that there are no duplicates. They will assume there are no duplicates. And in the output also, there will be no duplicates. Is this clear? So these three keywords, they use set semantics. Means the input, they will consider the input as set of tuples and they will consider the output also as set of tuples. They will produce set of tuples and they will assume that input is set of tuples. Okay, I hope this point is clear. So for example, if these are the tables R comma S, now let me give you some queries. Okay, tell me the answer for R union S. Is this a valid query? Is this a valid query? R union S. This is invalid SQL query. Okay, this is actually invalid SQL query. Okay, this is not valid. So what is valid query then? The valid query is like this. See, I can do this. So how to write R? I want to write R as it is. I want to write R as it is. So what I will do? Very simple. Select from R. This is same as R. Yes or no? Similarly, select star from S. This is same as S. Yes or no? This is actually equivalent to R. This is actually equivalent to S. That you already know. Okay. Now you tell me. Now you tell me. So if I do their union, how many tuples in the output? What will be the output of this? So the output, tell me the output. Okay. Important point again, I am telling you. This union, this uses set semantics, right? Yes or no? This union, this will use set semantics. So it will assume that your input table has no duplicates. Okay, so from the input table, just ignore the duplicates. See, from the input table, just ignore the duplicates. Ignore the duplicates in the input table. In the input table, ignore the duplicates. And the output also will not have duplicates. Okay, so the output will be like this. Output will be output will be A1, A2, A3, A4, A5. That's it. So five tuples. Is this clear? So output will have five tuples. So remember this union, this will ignore the duplicates, ignore duplicates in the input table. In the input table, ignore the duplicates. Or I can say first eliminate duplicates from the input table. Okay. Very simple. Ignore duplicates in input tables. Is this clear? So remember, first you ignore the duplicates in the input table, and in the output also, you must not have duplicates. Okay, and remove duplicates from output. Okay, so that's it. I hope you understood this. Now tell me, what will happen if I have intersect? What will happen if I have intersect? So again, the same thing will happen. This intersect, what it will do? It will ignore duplicates in the, remember, it will ignore duplicates in input table. Because remember, these, they will use set semantics. Yes or no? They use set semantics. They don't consider duplicate tuples. Okay, these keywords, they use set semantics. So this will ignore the duplicates in the input table. And output will also not have duplicates. So the output will be what? So the output will be very simple. Okay, intersection. Just do the intersection. So that will be A1, A2. That's it. So there will be only two tuples. Okay, so the output will have only two tuples. Is this clear? Simple, right? Now, what about except? What about except? Let me know. If I put except here, again, it will ignore the duplicates in the input table. First, you ignore the duplicates in the input table. In the input table, you remove the duplicates. And then in the output, don't put duplicates. So except means set difference. R minus S. Yes or no? Basically, you are doing R minus S. Okay, so only this tuple you will have A3. So there will be only one tuple, that is A3. Is this clear? Please tell me. Let me know. Okay, you are doing the set difference, R minus S. So only A3 tuple will be there. Only one tuple in the output. I hope all these points are clear. Now let's move on. Now let's see some more SQL keywords, that is union all, intersect all, except all. Okay, remember union all, intersect all, and except all. What these keywords will do? What these keywords are going to do? So tell me, union all, these are SQL keywords. And what is their purpose? Okay, so let me tell you, this union all intersect all, except all. These are the keywords, and their purpose is what? What do you think? What is their purpose? If you remember, union, what this does? This does set union, right? So what this union all will do? It will do bag union. Okay, intersect all, it will do bag intersection. And except all, it will do bag difference. Okay, is this clear? So remember, this keyword will do bag union, this keyword will do bag intersection, this keyword will do bag difference. Okay, very simple point. So these are the keywords. Okay, so remember, these keywords, they use bag semantics. They use bag semantics. What it means? It means that they will not ignore the duplicates, right? Yes or no? They will not ignore the duplicates. And in the output also, duplicates might be there. It is possible that output can have duplicates. They will not ignore the duplicates. So remember, they will use the bag semantics. So you can see the difference. SQL keyword, this is a keyword union, this is a keyword union all. What this keyword will do? This is used for set union, means this will treat the input as a set and produce set of tuples. Is this clear? This keyword will treat the input as a set. It will ignore the duplicates from the input and it will produce set of tuples. Union all, this is used for bag union, means it will treat the input as a bag and it will produce bag of tuples. Okay, similarly, intersect, this is a keyword. Intersect all, this is a keyword. You can see this intersect, this will use, this is used for set intersection. Okay, this is used for set intersection, means this will treat the input as a set and it will produce set of tuples. Intersect all, this is used for bag intersection. It will treat the input as bag and it will produce bag of tuples. Okay, very simple. Next, you can see this is a keyword except. This is another keyword except all. This keyword is used for set difference. It will treat the input as set, it will ignore the duplicates from the input and it will produce set of tuples. Except all, this is used for bag difference. It will treat the input as bag and it will produce bag of tuples. Okay, now let me quickly tell you what is bag union, bag intersection and bag difference. How to do union of two bag, how to do union or intersection of two bags, and how to find set difference, the bag difference, the difference of two bags. Okay, so let's see. Let me tell you, this is actually very simple. When I say bag union, then just do frequency union. See, this is actually very simple because in a bag, frequency matters. Do you agree with me? In a bag, frequency of element matters. So when I say bag union, then just do frequency union. And when I say bag intersection, then what you will do? See, these are very simple. In a bag, frequency matters, that you already know. So when I do bag intersection, then what you will do? Then you will do frequency intersection. Then you will do frequency intersection. And when I do bag difference, then what you will do? When I say bag difference, then what you will do? Then you will do frequency difference. Okay, is this clear? These are actually very simple concept. Frequency union, frequency difference, frequency intersection. Okay, so let's see this example. Look at this example. I want to do bag union. This is a bag, remember. Okay, remember this is a bag. Okay, you can see this is a bag. I want to do their bag union. Then what will happen? You will do frequency union. Okay, means, okay, basically you will take everything. You will take this one is 2 times and this one is 3 times. So in the output, one will be 5 times. You are doing frequency union. Please understand. Please understand, you are doing frequency union. One is 2 times, one is 3 times. So in the output, one will be 5 times. 2 is 1 time, 2 is 1 time. So in the output, 2 will be 2 times. 3 is 1 time. So in the output, 3 will be 1 time. Okay, is this clear? Simple, right? Agree with me. Next, bag intersection. This is a bag, this is a bag. You will do frequency intersection. Frequency intersection, 1 is 2 times, 1 is 1 time. What is frequency intersection? This element 1 is 2 times. Here the element 1 is 1 time. What is the frequency intersection? Frequency common. What is frequency common? Frequency common is 1 time. So you can see 1 will be 1 time. Next, 2 is one time, 2 is one time. So frequency intersection, 2 is one time. Next, you can see 3 is one time, 3 is zero time. So you can see here you don't have 3. So this is bag intersection. What is bag difference? Or I can say bag minus. That is frequency difference. See, this element 1 is 2 times. This element 1 is 1 time. So 2 minus 1. Frequency difference. Frequency difference. So this 1 will be 1 time. 2 1 time, 2 1 time. 1 minus 1 0. 3 0 time, 3 1 time. 3 0 time, 3 1. 3 0 time, 3 1 time. So that is minus 1. So you don't put 3. Okay, don't put 3. Is this clear? Let me know. Okay, in the same question, you tell me if I do 1 to 3 minus 1 to 1. Now tell me, now what will be the answer? 1 to 3 minus 1 to 1. You are doing bag difference. Okay, so remember, you will only have 3. That's it. Nothing else. Yes or no? Very simple. I hope this point is clear. So again, I'm telling you that bag union means frequency union. Bag intersection means frequency intersection. Bag difference means frequency difference. So these points are very simple. Okay. Now let's quickly see some points. Okay, let me give you some results. Some quick results. So let's assume you have two tables. Okay, let's assume there is two set R, and in this set, let's assume there are m copies of elements A. There are m copies of element A. Okay, and in this S, there are n copies of element A. They can be zero, right? Do you agree? Yes or no? So these are the bags. Remember, there is a bag S, there is a bag R. Okay, you have bag R and there is a bag S. Okay, so in bag R, you have m copies of element A and there are n copies of element A. So now, now you tell me, if you have these, then quickly tell me, in R bag union, these are bags. So you are doing bag union. In R bag union S, how many copies of element A? In this R bag union S, how many copies of element A? That will be m plus n copies of element A, because you will do frequency union, right? Yes or no? Copies of element A. Is this clear? Simple, right? Very simple result. So in this R bag union S, okay, in this there will be m plus n copies of element A. You will do frequency union. Okay, this is called frequency union. You are basically doing frequency union. Next, what about R bag intersection? I am doing bag intersection, remember? So if I do bag intersection S, now you tell me, in this, how many copies of element A? Tell me, how many copies of element A? Very good. You are doing the frequency intersection. Frequency intersection, so that will be whatever is minimum. Okay, minimum of m comma n. These many copies of element A. Yes or no? So what is this called? This is a frequency intersection. You are doing the frequency intersection. Okay. What about the last one? If I do R bag difference, R bag difference S. Okay, means R minus S. Now tell me, in this, how many copies of element A? Let me know. You will do the frequency difference. Yes or no? You will do the frequency difference. So m minus n. But that can be negative. So I can say whatever is max. Either 0 will be max or m minus n will be max. Whatever is max. Okay, these many copies of element A. These many copies of element A. Simple, right? Yes or no? Is this clear? Because when you do m minus n, it can be negative also. So that is the reason. Okay, 0 comma m minus n, whatever is max, that will be your answer. So this is your frequency difference. Okay, you are basically doing frequency minus. Okay, you are doing frequency minus. Simple. This is what you are doing. That's it. So you can see whatever we have seen, that is written here on your on this. You can read this. Okay, so that's it. Now let's see. Now let's come back to union all, intersect all, except all. I told you these keywords, they will use the bag semantics. Yes or no? These keywords, union all, intersect all, except all, they will use the bag semantics. Union all, it will do the bag union, it will do the bag intersection, it will do the bag difference. Okay, now you already understand all these concepts very easily. You can do yes or no. So can I give you, okay, let's see this question. In this question, if I ask you what is their union all, if I apply union all, then what will be the answer? See, tell me, is this a valid query? First of all, you tell me, is this a valid query? Is this a valid query? This is not a valid query, but this is only for understanding purpose. Actually, this is not a valid query. Okay. So let me give you, like, for example, let me give you valid query. Okay. See, valid query will be something like this. Okay. If I want to do, for example, R union S, I want to do, so what I will do? I will do select star from R. Okay. Union all. Union all. What I will do? I will do select star from S. Yes or no? Are they union compatible? This and this. If I want to apply union all, then they must be union compatible. Are they union compatible? Yes, they are union compatible. Yes or no? So this is the query. Now tell me what will be the output of this query? What will be the output of this query? You will do union all, means bag union. Just do the bag union. Okay, so how many tuples will be there? There will be total 8 tuples. Is this clear? So this is your query. This is your query Q1, and the output is this. Is this understood? Please tell me. Let me know. Simple, right? Very simple. Okay, similarly, you can do, if I do intersect all, what will be the output? So you can see, if I do intersect all, then you will do the frequency intersection. Okay, you can see A1, A1. So one time A1 will be there in the output. You can see. Okay, if I do intersect all, then this output I will get. You can see A2, A2 how many times I will get? Frequency intersection. Frequency intersection. So A2 I will get only one time. A3 0 time, A4 0 time, A5 0 time. So this is intersect all. Okay, next, this is your accept all. This is accept all, because you can easily see in the accept all what will happen. 1 minus 1 0, 2 minus 1, so A2 will be there. Yes or no? 1 minus 0, so A3 will be there. So this is the answer. I hope you understood. You can see this. Let's move on. So I told you that these are the SQL keywords: union, accept, intersect. These are SQL keywords. They use set semantics. They will ignore the duplicates in the input, and they will not produce duplicates in the output. And these union all, accept all, intersect all, they use bag semantics. So they will do frequency union, frequency intersection, frequency difference. Is this clear? Let me know. Please tell me, did you understand these 6 keywords? Let me know. So these keywords will use set semantics. They will ignore the duplicates in the input, and they will not produce duplicates in the output. Okay. So everything that we have seen, everything is written here. You can see this is very beautiful slide. Okay. See this bag number 1 and this is bag number 2. Is this a valid query? Is this a valid query? Yes, this is a valid query. Basically, we are doing union all, bag union. So what will be the output? You are doing union all, bag 1, union all, bag 2. They are union compatible. You can check. Yes, they are union compatible. So I can do union all. Now the frequency union will happen. Apple 2 time, Apple 1 time, so Apple 3 time. Okay, tell me, order of tuples matter or not? Let me know. Order of tuples matter or not? Order of tuples doesn't matter. Yes or no? I told you that bag is unordered. Bag is unordered. So unordered tuple, unordered collection of tuples. So remember, order of tuples doesn't matter. You can put all the 3 apples together, no problem. Order of tuples does not matter. So you can see 3 apples will be there. Yes, there are 3 apples. Next, 3 oranges will be there. Yes, there are 3 oranges. Okay. Here accept all. Frequency minus 2 minus 1, that will be 1. So apple will be there. 1 minus 2, so orange will not be there. Intersect all. Do the frequency intersection. 1 intersect 2, so there will be apple one time. Okay, 1 intersect 2, there will be orange one time. So you can see this. Let's solve this UGC NET August 2016 question. Consider the following oracle relations. Two relations are given to you. This relation has two attributes and these are the tuples. This relation has two attributes and these are the tuples. Consider two SQL query. These two SQL query are given to you. This is query number 1. This is query number 2. For each of these queries, what is the cardinality, means number of tuples in the result obtained when you apply these queries on these instances. Okay, so these queries, these two queries, we have to apply on these instances and we have to find out how many tuples will be there in the output. Okay, so let's see this. First of all, you tell me what is the first query. Let me know. Look at query number 1. What query number 1 is doing? Select star from 1, select star from 2, accept. So basically this query number 1, what this is doing? See, this is basically, it's something like this, that from this table, this table 1xy, from this table you are removing this table. Okay, yes or no? From this table 1xy, accept this table 2xy. Okay, so tell me, this accept, is this set difference or is this bag difference? This accept in the SQL, this is a set difference, yes or no? So remember, this is a set difference. What it will do? It will ignore the duplicates in the input and it will not produce duplicates in the output. Yes or no? Do you agree? This keyword, this will ignore the duplicates in the input and this will not produce duplicates in the output. Okay, what about this one? Select star from 1, select star from 2, accept all. So this query, this is basically, it's like 1xy, accept all, 2xy. Okay, and this accept all, this is your bag difference. This keyword is used for bag difference. Okay, frequency difference, yes or no? This will do frequency minus. It will do frequency minus. Okay, so now very simple. You have these two queries, SQL1, SQL2. So you tell me what SQL1 query will give you output and what SQL query 2 will give you output. Okay, here you have accept 1 minus 2, accept. Here you have this keyword accept and here you have this keyword accept all. Okay, so what this query will actually do? It will ignore the duplicates. First, let me tell you about SQL query 1. Okay, so you accept. So what it will do? It will ignore the duplicates in the input. Yes or no? Just ignore the duplicates in the input. Ignore the duplicates in the input. Agree? Yes or no? For example, you can see 1 6 you can ignore, 4 8 you can ignore. Okay, you can see 2 5 5 1 1. So that's it. Okay, now you just do okay, from 1 minus 2. 1 minus 2. So tell me, how many tuples will be there? So you can see this tuple will be there in the output, yes or no? Okay, so in the output, this tuple will be there, 2 5. This tuple will be there. Okay, this tuple will be there. This tuple will not be there. Okay, because you are doing minus. So this tuple will not be there. This tuple will not be there. So that's it. This will be your output. Okay, so remember, SQ1, this query will produce only one tuple. Output has one tuple. Only one tuple will be there in the output. That's it. Very simple. What about SQL2? What about query 2? Accept all. This will do the frequency difference. Okay. What is the frequency of 2 5? It will do the frequency difference. Okay, 2 5 frequency is 1. And here 2 5 frequency is 0. So 1 minus 0, that is 1. Okay, so remember, the output will have 2 5. What else? Next, what is the frequency of 1/6? That is 3. Frequency of 1/6, that is 2. So 1/6 will come one time. 3 minus 2, one time. Yes or no? Next, what is the frequency of 4/8? 2 times. Yes or no? Frequency of 4/8, that is 2 times. Here frequency of 4/8 2 times. So 0 time. That's it. Okay. So there will be two tuples in SQ2. In this query, there will be two tuples. So that's it. Finally, your answer will be, for this question, answer will be 1, 2 respectively. Answer will be option B. So this is a good question. Yes or no? This type of question they can ask you. Very simple. Okay. Did you notice one thing? The question is not directly asking you this statement. See, the question is not directly giving you this statement because this is not a SQL query. Yes or no? From this table minus this table, directly the question is not giving you this because this is not a SQL query. You have to write like this: select star from 1. That simply means this table 1. Select star from 2. That simply means this table 2. Similarly here, select star from 1. That simply means this table. And select star from 2. That simply means this table. Okay. Now let's move on. Now let's see some SQL queries using union, intersect, except. Actually, let me tell you one thing. A lot of tricky questions can be created based on union, intersect, and except. And I am taking all the tricky questions, all the tricky variations that can be created in the GATE exam based on union, intersect, except. Okay, so let's start. You use your mind, you use your brain. So tell me the answer for this question. Output of the following query, what is that? Just think about it and tell me. Just take your copy pen, create the diagram, create the idea, and you tell me the answer. Output of the following query from these tables: seller, reserve, bought. Okay, all these three tables we are using, where this is the tuple selection condition: SID equal to RSID, RBID equal to bought BID, and either the color is red or the color is green. Those sellers names we want. Okay, we are projecting seller name. So what is correct output? Color is red or color is green. So name of seller who have reserved green or red bot, green and red bot, empty table. What is the answer? So for this question, the answer will be option A. There is nothing tricky here. This is very simple question. See what this question is saying. Just consider the idea. Okay, just create the idea. These are the tables. Sellers table is there. Reserves table is there. And bots table is there. Okay, these are the tables. Now in the sellers table, you have SID and there is S name. Remember, we want this S name in the output. Okay. Next, in this, here you have SID, you have BID. And in the bot, you have BID and you have color. Okay. And what the question is saying? The question is saying that this type of tuple we are looking for where seller SID equal to reserve SID means this SID. For example, if you have 102 here, you have 102 here. So they must be same. Okay. So this seller is booking RBID, BIBID, they are same. For example, if you have 20 here, then 20 here, they are also same. And color must be, what this color must be? Here in this tuple, either you must have red or you must have green. Either you can have red or you can have green. Remember, in this tuple here, in this cell, either you can have red or you can have green. Okay, these seller names we want. Seller names in the output. So very simple point. This type of tuple we want where we want the name of sellers who are booking a bot whose color is either red or green. Yes or no? Very simple. Here, either you must have red or you must have green. Simple. Yes or no? Is this clear? So very simple that we want name of sellers who have reserved a red or green bot. So the answer will be option A. Tell me the answer for this question. If I do and, if I put and here, means boat color is red and boat color green. So can I say that name of seller who have reserved a red and green boat, option A? Can I say answer is option A? Name of seller who have reserved a red and green boat. Can I say answer is option A? The answer actually will be empty table. See, just take your copy pen and think about it. Just create the diagram. If you create the diagram, you can solve any question, any tricky question you can easily solve. Okay, see, the question is saying these three tables we are using. This is the selection condition and we are projecting as name. Okay, again, what you do, just create the table side by side. If you create the table side by side, you will see what is happening here. Okay, you have seller table where you have SID and you have S name. This S name we want in the output. You have reserves table where you have SID and you have BID. And there is a bot table where you have BID and there is color. Okay. Now the question is saying that we want this type of tuples. See, the question is saying tuple condition is given, right? This is the tuple condition, tuple selection condition. Which tuple we want? Tuple selection condition. So which type of which type of tuple we want? So we want this type of tuple where seller SID equal to reserve SID, reserve BID equal to bot BID, means this seller SID, this must be same as reserve SID, and this BID, this must be same as this BID. This S name we want in the output, and color must be red and color must be green. Okay, means in this tuple here, you must have the color must be red also and the color must be green also. Is it possible? See, in this cell, you must have red also, green also. Is this possible? Either you will have red or you will have green. Can you have red and green? Okay, yes or no? See, very simple. That color must be red and color must be green. Means in this tuple, you must have red and green here in this cell. Yes or no? Here you must have red and green. Can you do that? Is it possible? Will you ever get this type of tuple? Tell me. In the cross product of these three, if you do the cross product of these three, will you get this type of tuple where you have red and green both simultaneously? Simultaneously? No, you will never get. So empty table. Yes or no? So this type of tuple never possible. This tuple not possible. So empty table. Yes or no? So the output will be empty table. Okay. So finally, for this question, answer will be option C. Is this clear? Agree or not? So this is the tricky question. Do you agree with me? In the gate exam, many people they can click this. Okay, that reserved a red and a green bot. Okay, many students they will click option A, but actually the answer is option C. I hope you understood the logic. So tell me, in the gate exam, will you create this type of idea? Yes, always create this type of side by side table and just think about what type of tuple you want. Okay, let's see this. So what is the correct query then? What do you think? What is the correct query? I want sellers who have reserved red and green bot. Okay, those sellers who have reserved a red bot and a green bot. So what is the query then? See, very simple point. What you will do? You will need multiple tables. Yes or no? Okay, remember, you will have this type of situation. That seller, you will have, okay, now this reserve, see, let me tell you what you actually want. What you actually want, let me tell you. Then you will understand what I want and what you actually want. Bots. Actually, this is what you want, that this seller ID, this SID. Yes or no? See, this is what we actually want, that this SID, this 102, this we want in the output. What this 102 should do? This 102, what this ID must do? This ID must book a bot with red color. Agree? We want those sellers who have booked a red color bot and a green color bot. Basically, those sellers we want who have booked at least two bots, one red color bot, one green color bot. Yes or no? So I want this type of tuple where this seller has booked, this seller 102, this is booking a bot with red color. But I also want that this seller, another reserves table I will take. Another reserves table I will take. That this seller, okay, this same seller, remember, this same seller 102, this is booking another bot, maybe 25 number bot, whose color is green. I will take another bots table. Yes or no? So remember, we need 5 tables we need. Is this clear to everyone? Please tell me. Now you can see this type of tuple I want. I want this type of tuple where this seller is booking a bot with red color and this seller is booking a bot with green color. Is this clear? Let me know, please tell me. So this is your query. This is the idea. I hope you understood. Is this clear? Let me know. So this idea is clear. Now you can write this query. You can see seller table one time, reserve table, bot table, reserve table, bot table. Seller table, reserve table, bot table, reserve table, bot table. 5 tables we are taking, and this is the query we can write. Okay, you can easily write, and you are projecting as name. So this is the idea. I hope you understood. Okay, so remember, they must be same, they must be same, they must be same, this must be red, they must be same, and they must be same. Okay, like this. So anyway, very easily you can do, you can easily solve this question. So I hope you understood, and this is the final query you can read. Now let's move on. Tell me the answer for this query. For this query, can I say this is the output? Is the following query output correct? I am asking, is the following query output correct? Is this correct output? Is this correct output? Think about it and tell me. Tell me what this is doing. Okay, see, there is union here. Tell me what this is doing. Just tell me, just simply tell me what this is doing. These are names of people who are booking a red bot. Names of people who are booking red bot. So these are names of red bot people. Seller names. Seller names booking red bot. Yes or no? Booking a red bot. And these are seller names booking a green bot. Seller names. Okay. And then we are doing the union of them. So will it give me seller names who have reserved a red or a green bot? Sellers who have reserved a red or a green bot, will it give me? Yes, it will give me. There is no problem. See, very simple. What you are doing? See, first you are finding all the red bot people. Okay, remember what we are doing. See, first we are finding as name of red, those who are booking a red bot. Okay, let's assume these people are booking a red bot. Let's assume these people A, B, C, A. These 4 different people. 2 different people can have same name. Yes or no? So let's assume these are the red bot people. These are the red bot people. Okay. Yes or no? Then we are doing union. We are doing union with what? Union with green bot people. These are the S name of green bot people. Let's assume the green bot people, for example. Okay, these are the green bot people. Now, very simple. So finally, I can say these are the green bot people. Do we want their union? You just tell me this point. Do we want their union? Do we want their union? These are the red bot people, these are the green bot people. Do we want their union? Very simple point I'm asking. Name of sellers who have reserved a red bot or a green bot. Will it give me, if I take union of this and this, if I take this union as this is given in the question union. Red board people, union green board people. If I take their union, will I get this answer? Name of seller who have reserved a red bot or a green bot. Yes, the answer is correct. Yes, this is correct. Okay, now a simple question I'm asking. Yes, this is correct. Yes, this will give me all seller names, all sellers names. This will give me all sellers names who reserved, who reserved a red or a green bot. Okay, okay. One simple question I'm asking you. Please tell me, does it matter to you? Is this B and this B they are same? See, they can be different seller, right? Does it matter to you that this B and this B they are same seller or different seller? Does it matter to you? Does it matter to you this B and this B they are same seller or different seller? Does it matter to you? Does it matter to you that they are same seller or different seller? Maybe they are different seller with same name, or maybe they are same seller. Does it matter to you? It doesn't matter. Yes or no? We want all sellers who reserved red or green board. So it doesn't matter whether they are same seller or whether they are different seller. It doesn't matter. So very simple. So finally, remember, is this query output correct? The answer is yes. Okay, this is the correct output. Remember, this is the correct output. The answer is yes. Okay. Now let's see this query. Is this query output correct? If I do intersect of red people, green people, if I do their intersect, will I get name of sellers who have reserved a red and a green bot? Will I get common people? Simple question. See, very simple. Let's assume, first of all, you notice what this query will give you. These are red bot people or not? This will give you names of red bot people. Yes or no? Names of red bot people. Correct. And similarly, this query will give you names of green bot people. Yes, correct. Names of green bot sellers. Okay. Now I am doing their intersect. See, maybe this type of situation happens. See, notice. See, these are the red. I got red bot sellers. Red bot sellers names. I got them. Okay, let's assume these are the red bot sellers names. A, B, A, C. Okay. And I am doing their intersect. Intersect with green bot sellers names. Okay, yes or no? For example, maybe here you have B, D, B. Okay, maybe this is what you have. Now you just tell me, if I do their intersect, see, these are the people. These are the people who are booking red bot. These are the people who are booking green bot. If I take their intersection, I will get those people who are booking red and green. Yes or no? That's correct, right? So where is the problem? See, if I take their intersection, these are the people who are booking red bot. These are the people who are booking green bot. If I take their intersection, I will get the names. Okay, just take the intersection. If you take the intersection, then what I will get? I will get the names of those people. I will get the names of those people who are booking red and green. See, this is booking red and green. This is booking red and green. Yes or no? See. This is this person. This person is booking red and green. This person is booking red and green. So finally, I got names of those sellers who are booking red and green. Is this so? Can I say names of seller who are booking red and green? Is this correct? Let me know. Name of seller who are booking red and green. Is this correct? No, there is a problem. No, there is a problem. There is a problem. No. Where is the problem? You tell me. See, the problem is this. Okay, what if, see, what if this person, this person, this person, what if they are different people? Three different people having same name. So, should we have B in the output? See, assume three different people have same name. Assume three different people have same name. This is a different seller, different seller, different seller. They have same name. So should we put B in the output? If I want sellers who are reserving red and green bot, remember these are sellers. These are sellers names who book red and green bot, who book a red and green bot. Okay, now you just tell me very simple point. Assume these three are different people, same name. Assume these three B. Okay, see this B, this B, and this B. Assume three different people, same name. Three different sellers, but same name. It can happen, right? Three different people, same name. So we should not have B in the output. Yes or no? Do you agree with me? We should not have B in the output. We must not have B in output. But this query will give you B in the output. See this query will give you B in the output. Yes or no? This intersect, this query will give you B in the output. But actually, name of seller who are reserving red and green bot, according to this, B should not be in the output. So did you understand that this query is actually wrong? Let me know, did you understand? Please tell me. Very simple point. It's like this. See, it's like this. Let's assume, okay, there is a Babu Rao. There is a Babu Rao here who is booking a red bot. Okay. And there is another Babu Rao from parallel universe who is booking a green bot. Okay. Yes or no? They are actually different people. They are actually different seller with same name. They are actually different sellers. Okay. But their name same. They are different seller with same name. So actually, we should not have Babu Rao in the output. Yes or no? Okay. Can I say Babu Rao has booked green and red bot? Can I say, Babu Rao has booked red and green? Babu Rao should not be there in the output. Yes or no? Babu Rao must not be here. This Babu Rao will not go in the output, right? But if you do intersection of these, then Babu Rao will be in the output. Yes or no? Is this clear? Did you understand? See, ideally, Babu Rao should not be in the output, but if you do their intersection, Babu Rao will be in the output. Okay, yes or no? So ideally versus actually. So this is what I'm saying, that this query, look at this query, this is doing intersection. Red people name, green people name, you are doing their intersection. So this query does not give you this output. I hope you understood. So this type of question they can ask you in the GATE exam. And this is a major, I can say, major mistake prone question, right? Many students will make mistake here. Many students are going to make mistake here. Can you tell me why the mistake is happening? Can anyone tell me why the mistake is happening? What is the reason for mistake? You tell me why the mistake happened. Why this query, where this query failed? This query failed, I know, but where this query failed? This query failed because as name, this is not a key. Yes or no? Very good. This is non-key. This query is failing because two different people can have same name Babu Rao. Okay, so remember, this is a non-key. This is non-key attribute. So that is the reason this query is failing. If I use SID, will this query fail? If I use SID, now will this query fail? Tell me. Okay, I am asking, in the same query, if I use S in the intersect, if I use SID, here SID, here SID, SID is of all seller who is of red bots and green bots. Now will this query pass? Yes or no? Now this is a key, right? Now will this query pass? The answer is yes. Is this query correct? The answer is yes. Okay, now this query is correct because this is key. You cannot have two different seller with same ID. We cannot have different seller with same SID. So now this query will pass. So all these tricky variations I am telling you, are you understanding? Let me know. Remember, many gate questions can be created in the future. In the future gate exam, this type of question can come, and a lot of students will make mistake. I don't want you to make mistake. I want you to understand the logic. Just understand the logic, what is happening. Okay. So far, everything is clear. Now let's see this. Tell me the answer for this. Is this query output correct on your screen? Now we have accept. Again, red bot people. See, these are the SID who are booking red bot. These are the SID who are booking green bot. Now, can I say if we take accept, then we will get SID of all sellers who are reserving red bot but not green bot. Now this is correct. Yes, this is a correct. Okay, now you can see this is correct. This is correct. Why? See, from the red bot people, from the red bot SID, you are removing green bot SID. Okay, so we will get those sellers who are booking red bot but not green bot. Okay, and you can see this is a key, so there is no problem. Two different seller cannot have same SID. Two different seller, they cannot have same SID. So this is a correct query. Yes or no? Is this clear? Accept. From the red SIDs, from the red SIDs, we are removing green SIDs. Okay. Those SIDs which are booking a red bot, from that we are removing those SIDs which are booking a green bot. So we will get those SIDs, we will get those sellers who are booking a red bot but not a green bot. We will get those sellers who are only here, who are not here. Okay. So yes, this correct. This is a correct, because remember these are keys. This SID is a key. Okay. Is this clear? Now in the same question, if I put S name, in the same question, if I put S name, now tell me, is the output correct? S name minus S name, S name minus S name, green S name minus red S name. Will I get those sellers who are reserving red bot but not green bot? The answer is no. But tell me why. The answer is no. See what we are doing. We are doing red S names. We are doing red S names minus green S names. Okay. And remember, this is not a key. This is not a key. So where is the mistake? Give me a situation where this query will fail. Give me a situation where this query is going to fail. Where this query will be fail. Very simple. Consider this situation. Let's assume that you have, okay, just consider this situation. Let's assume you have seller. Okay, I'm giving you this situation that you have this SID S1 and SID S2. Let's assume this person is booking red bot and his name is Babu Rao. Okay, is this clear? And this seller, this different seller with same name, different seller with same name is booking green bot. Okay, now you tell me this Babu Rao should be in the output or not? The first Babu Rao should be in output or not? Let me know. Ideally, okay, ideally what should happen? Ideally, first Babu Rao should be in the output, because this Babu Rao is booking red bot but not green bot. Look at the first Babu Rao. This first Babu Rao is booking red bot but not green bot. Ideally, this Babu Rao S1. Okay, ideally this Babu Rao, who S1 Babu Rao. Yes or no? Ideally Babu Rao, because of S1. Because of S1. Ideally this Babu Rao must be in output. Must be in output, because this Babu Rao, this first Babu Rao is booking a red bot but not a green bot. So ideally this would happen. But what this query will do? But this accept query, what this will do? Will remove Babu Rao. Yes or no? Will remove Babu Rao. Okay, from this minus Babu Rao minus Babu Rao. Babu Rao minus Babu Rao, so Babu Rao will be removed. Yes or no? Is this clear? So that is the reason I can say that this accept query, S name minus S name, okay, red S name minus green S name, this query will not give you your desired result. This query will not give you those sellers who are booking a red bot but not a green bot. So this is a wrong query. So we have seen all the all the tricky questions we have seen, what are the conclusion you would like to draw? Tell me, some conclusions can we draw from our analysis? Some conclusions I want to write. What are those? The first conclusion, the dangerous combinations. You tell me about the dangerous combinations where you should take care. What are the dangerous combinations? Tell me. Let me know the dangerous combinations. The dangerous combinations are non key minus non key, non key except non key. Yes or no? Non key except non key. This is a dangerous combination or not? You should take care. I am not saying that this will always be wrong. Yes or no? Can I say this will always be wrong? Non key minus non key. Can I say this will always be wrong? I am not saying. I am saying this is a dangerous combination. When you see this type of situation, you should take care. You should do analysis. Okay, what about non key intersect non key? What about non key intersect non key? Tell me. This is also dangerous combination. Yes or no? What about union? Is that dangerous? If I do union, is that dangerous? That is not dangerous, right? Yes or no? Non key, union, non key, that is not dangerous. This is a not danger. This is not dangerous. Okay, I hope this point is clear. And what about key minus key? Okay, not dangerous combinations. Now I want to tell you not dangerous combinations. What are those? For example, key minus key. That is fine. Key attribute minus key attribute. Okay, key attribute intersection key attribute. That is fine. Key attribute union key attribute. That is also fine. Okay, all these are actually not dangerous combinations. So that's it. Okay, so many combinations can be created. Remember, I hope all these points are clear. So let's move on now. So we have seen this. Okay, let's move on. Write SQL query to show only the distinct tuples of the input table. Write SQL query. We only want to show the distinct tuples of the input table. So tell me, can I write like this? For example, if I want only the distinct tuples of the input table I want, then what I can do? The query number one query I can write is distinct. I can use distinct, yes or no? I can use select distinct star from R. Yes or no? That's it. Okay, select distinct from table. That's it. Very simple. Can you give me some other creativity? Can you give me some creativity? Using intersection? Using intersection, I can do. See, query 2. What I can do? I can do intersect or intersect all. Should I do intersect or should I do intersect all? Should I do intersect or should I do intersect all? Select star from R. Intersect. Yes, I should do intersect because intersect will remove the duplicates. It will remove the duplicates. Select star from R. So remember, this intersect will remove duplicates. Yes or no? It removes duplicates. Simple. So I can do this. So this is the query 2 I can use. Is this clear? So this is another application of intersect. You can do intersect. Can I do union? Tell me, if I do union, can I do union? Union will also work. Yes or no? Union is also going to work. Okay, so remember, you can do union also. So that is also fine. You can do union also, you can do, that is also fine. Because union will also remove the duplicates. Okay, so union also you can do. Okay, can I do except? Except I cannot do. I can do intersect, I can do union. These are fine. Okay, so that's it. Now let's see the next topic, that is aggregate operators. Should we discuss this in the next session or should we continue? So let's study SQL aggregate operators. This is the next topic. In SQL, there are some aggregate operators and let's study them. Let me tell you one thing. For now, we will assume that there are no null values in the tables. Okay, this is actually the null values I will discuss. I will discuss everything about the null values, how to handle the null values. But for now, we will assume that there are no null values in the table. Remember, we will shortly study about the null values also. Okay, so for now, assume that there are no null values in the table. Now let's move on. So in SQL, there are 5 aggregate functions. These are AVG, that is used for average, MIN, this is used for minimum, max, this is used for maximum, sum, this is used for total, and count, this is used for count. Remember, these are the keywords. Average is not a keyword. So tell me which is a keyword? SQL keyword. See, AVG is a keyword. This is a keyword, but average is not a keyword. Is this clear? Average is not a keyword. So remember, these are the keywords. These are SQL keywords. Okay. And what they will do, what these aggregate functions, what they actually do, they summarize, right? They provide summary. They provide summary. Okay. For example, if I want to find out what is the average, then that is a summary. What is minimum? What is total sum? What is total count? So that is a summary. So remember, aggregate functions, they provide summary. They summarizes your column, your attribute. Okay. And these are the keywords. These are the 5. And these are very intuitive. Okay. You already understand, for example, what this minimum will do, what this keyword will do. It will provide you the minimum, it will provide you the maximum value, it will provide you the total summation, it will provide you the total count, and it will provide you average. And what is average? How to find the average? How to find the average? That is total divided by count. Yes or no? Total divided by count. That is your average. Very simple. So these things are very simple. Now, let's move on. Okay, let's see the syntax. Let's see the syntax of these aggregate operators. The syntax is like this. Okay, let me tell you, the syntax is like this. For example, this min. Okay, in the bracket, you will write attribute name. Is this clear? This is the syntax. Here you will write attribute name. This is a attribute name. Okay, this is the syntax. Min A. What this will give you, tell me? This will give you in this attribute A, what is the minimum value? Yes or no? So remember, this is the syntax, min A. Similarly, max A, attribute name. Similarly, count A, attribute name, remember. Similarly, sum A, AVG A. Is this clear? And we already understand what they will do. Okay, we naturally understand. Yes or no? Their semantic we naturally understand, right? Semantic. Okay, their behavior we naturally understand. Their name itself is telling you. We naturally understand. Okay, so remember, this is the syntax. Now, what you can do, you can also put, if you want, you can put distinct also. For example, if you want summation of distinct values, sum distinct, you can put distinct also. Okay, distinct A. So if you put distinct A, then what will happen? Then you are doing summation of distinct values. Is this clear? If I put, for example, count distinct A, then this will give me count of distinct values of A. If I ask you what is average distinct A, then this will give me average of distinct values of A. Okay, tell me about this. Minimum distinct A. Does it change? Does it matter? If I ask you minimum in the distinct values of A, will it be same as minimum in the all the values of A? Yes. Remember, this will be same as min of A. And similarly, max. If I put distinct, I can put, this is not an error. Okay, don't worry. This is not an error. I can put, you can put, no problem. You can put distinct, but the result will be same as max of A. But here, remember, these, okay, they will ignore the duplicate and calculate. Yes or no? Ignore duplicates and calculate. ignore duplicates and calculate. Very simple. Okay, so here we are doing the summation of distinct values of A. So remember, you ignore the duplicates and then you calculate. Very simple. So this is the syntax. I hope you understood. Now let's see some examples. But before that, one more thing I want to tell you, that is count star. This is a special. Again, I'm telling you, don't confuse count star with count of A. See, we have seen count of A. This is different. This is different. Count, okay, but count star is different. This is very special. I can say this is a special. Okay, what this count star will do? It will always calculate the number of tuples. It will always calculate count number of tuples. Number of tuples in the table. That's it. Okay, it will always count number of tuples in the table. In the table. That's it. Okay, is this clear? This will always calculate, this will always count number of tuples in the table. Also, you cannot put distinct with count star. For example, count distinct star. Count distinct star. This is a invalid. Okay, is this clear? This is error. I can say this is a, okay, this is error. So again, I'm telling you, very important thing I'm telling you, that don't confuse count, this, don't confuse this count of A and this count star. They are actually very different. Okay, sometimes they can be same, sometimes they can be same, but when you have null values, then they are very different. Okay, is this clear? When you have null values, don't worry, but the point is simple. Don't confuse them, don't mix them, never mix them. Study them separately, study this separately, study this separately. Okay, this will count the number of A's, the number of values of A, this attribute A, and this will count number of records, number of tuples in the table. Okay, so don't mix them. This is my suggestion. Don't mix them. Study separately. Okay. Their behavior is also very different when you have null values. When you have null values, then they will behave in a different way. But anyway, so don't mix them, study separately. And remember, this will always, whether you have null values, whether you don't have null values, this will always what it will do. Okay, actually, this is very simple. This count star, this will always count number of tuples. That's it. That's it. This will always count number of tuples in the table. Okay. So very simple. I hope this point is clear. Now let's see. If this is your table, then what will be sum of B? Let's quickly see. If I ask you sum of B, what that will be? That will be 2 plus 4 plus 2 plus 2. Okay, so the answer will be 10. Yes or no? Very simple, sum of B. Okay. Now tell me, what will be sum of distinct B? What will be sum of distinct B? What that will be? If I ask you sum of distinct B, I told you this we can use this distinct keyword, we can use sum of distinct B. That will be 2 plus 4, that will be 6. Okay, so that is going to be 6. Okay, next, what about min of A? Min of A is 1. Yes or no? Minimum of A, that is 1. What is min of distinct A? That is also 1. Okay, that is also 1. That is same as min of A. Next, what is max of B? That is 4. Max of B, what is the maximum value? And what is max of distinct B? That will also be 4. That is same as max of B. Okay, correct. Next, what is count of A? That will be 4. Yes or no? Count of A will be 4. If I ask you count of distinct A, count of distinct A, what that will be? Distinct A, count of distinct A, that will be 2. Okay, yes or no? Very simple. What about average of A? That will be total divided by count. Total divided by count. Yes or no? So total divided by 4. What is average of distinct B? Distinct A. Average of distinct A. This AVG of distinct A. So what you will do? Very simple. Remember, this is same as sum of distinct A divided by count of distinct A. Okay, is this clear? Sum of distinct A divided by count of distinct A. So remember, this average of distinct A, that will be, I can say that will be 1 plus 3 divided by 2. So that will be 2. Is this clear? Let me know. So 1 plus 3 divided by 2. So very simple. Okay, remember average of distinct A, that is sum of distinct A divided by count of distinct A. Very simple. So that's it. Now let's see this. This is the table that is given to you. Now the question is asking from R, from this table, select sum A, count A, max B, min B, average B. So what will be the out? In this table, what is count star? In this table, what will be count star? Count star will be always, it will always count number of tuples. So that's it. Count star will be 4. Okay, count star, that is 4. Now let's see this. So from R, select, these are the, you can see in the select, you can see in the select we can put aggregate operators. Yes or no? You can see in the select clause we can put aggregate functions. Yes or no? So remember, your output will be what? If you do this query, then output will be this. Okay, output will have, these will be the attributes: sum A, count A, max B, okay, and so on, right? You are getting the point. So tell me, what is sum A? Sum A, that is 1 plus 3 plus 3, that is 7. Okay, it will happen like this. So you can see this is the tuple, you will get 7. Count A, count A is 3. Next, what is max B? Max B is 4. Okay, next, what is min B? What is min B? Min B, that is 2. Okay, and finally, what is average B? Average B, that will be summation divided by total. So you can see 3. So that is 9 divided by 3, that is 3. Okay, so that's it. Very simple. And what will be count star? And if I put count star also, then what will be count star? Count star will be 3. Okay, so that's it. Very simple. All these points are very simple. So we have already seen that you can use this distinct or you can use without distinct. Okay, this will do the counting, this will do the summation, this will do the average, min, max. Okay, now let's see this. Remember, I told you distinct is not allowed with count star. Yes or no? We cannot, remember, SQL does not allow distinct with the count star. This I already told you. So count star is special. Yes or no? Count star is special. I told you that count star is special. You don't have count distinct star. You cannot put distinct star. No. Count star is special. Very simple. Okay. Next, you can see. You can use distinct with min and max, remember, but it will not change the result. You can see it is legal to use distinct with min and max, even though the result will not change. Okay. So this is another point. Very simple. Now let's move on. So whatever we have seen that is written here, you can read it. Okay. Now let's see this. Find the average age of all sellers. How many tables you need to answer this query? How many tables you need? Tell me. I want average age of all the sellers. So only one table we need, that is sellers table. Yes or no? So very simple. From the sellers table, what I need? I just need, so select. I need average age of all the sellers. I need AVG, average age. Yes or no? AVG of age, that's it. So this is your answer. Okay, I want average age of all sellers. So that is very simple. And that will be AVG of age. So like this you can do from sellers as, you can use alias. Okay, you can use this alias AVG of s dot age. So like this you can write. Let's see this. Find the average age of sellers with rating greater than 10. How many tables you need? How many tables you need? Let me know to answer this question. See, rating is here. Rating is here. and age is here. So only this table we need, sellers. That's it. So the query will be what? Query will be from sellers table. From sellers table, remember what I want? I want only where. I will put the where clause I will put, because with rating greater than 7, I only want those people who have rating greater than 7. Yes or no? So where rating is greater than, sorry, rating of 10, rating is equal to 10. Okay. Yes or no? I want those people who have rating equal to 10 of 10. So where rating 10, then very simple. Here I will put select average age. Yes or no? AVG age. That's it. Very simple. So this is your answer. You can see this. I will select where clause. I will only select those tuples where rating is equal to 10, average of age, AVG age. Okay. Now consider this query and tell me, is this a valid query? In the select clause, can I use SID comma max age? Means I'm using aggregate function. I'm also using a attribute. Can I do this? Can I do this? No, this is illegal. Okay, remember this is invalid. This is invalid query. This is invalid query. Very simple. This is invalid query. Remember, when you have this aggregate in the select clause, when you are using aggregate function, then you cannot use unaggregated attribute. Okay. Is this clear? I will also teach you when we study this group by clause, then you will see that when you have group by, then we can do this. Okay. When you have group by clause, there is a group by clause. So there is a group by clause. When you have group by clause, then you can do this, but that we will study after some time. Okay. So don't worry about that. For now, you just see when there is no group by. Remember, when there is no group by, then in the select clause, you cannot use unaggregated attribute when you have aggregate function. If you are using aggregate function in the select clause, you cannot use unaggregated attribute. Okay. Is this clear? So very simple. This is the note. When there is no group by, remember, when there is no group by, then if we are using aggregate function in the select clause, then no unaggregated attribute is allowed unless there is a group by clause. Okay, unless there is a group by clause. If there is a group by clause, then it is allowed. Okay, if there is a group by clause. But if there is no group by clause, then if you are using aggregate function, then you cannot use unaggregated attribute. Okay, is this clear? So remember this query, this is invalid query. Yes or no? Remember, there is no group by, first of all. No group by. You are using aggregate function. Now you cannot use unaggregated attribute. So this is actually invalid query. This query, you can see, this is illegal in SQL. Okay, very simple. Now let's move on. Now tell me, if I want name of oldest seller, then can I write this query? I want name of oldest seller. Then can I write this query? I want name of oldest seller. Oldest seller I want. Then can I write this query that from the seller table, where age is equal to max age? Where age is equal to max age. So can I say this query is correct? This query is not correct. Why? This query is not correct. Why? Because where clause will apply on every tuple independently, individually. I already told you that where clause, this is tuple selection condition. This will apply on one tuple at a time, independently, individually. Yes or no? Tuple selection condition. Tuple selection condition applies on one tuple at a time. Tuple selection condition applies on one tuple at a time, at a time, individually, independently. Is this clear? Okay, see what this query will do. Notice what this query is going to do. Consider this query. I am putting age is equal to max age, right? Yes or no? See, this is my purpose. Name of oldest seller. Oldest seller. So from the seller table, where age is equal to max age. Okay, we are thinking, if you look at this query, it looks like correct. Okay, it is looking like a correct query, but actually there is a problem. What the problem? See, okay, just consider. Let's assume these are the sellers. Okay, and this is seller name, and this is a age. Now let's assume that this is seller name A, B, C, D, and these are the ages 20, 21, 22, 23. Now you tell me, remember, from seller, that is fine. This is your seller table. Okay. Now where age is equal to max age, this will apply at one tuple at a time. Okay, yes or no? Remember, this will apply one tuple at a time. Okay, yes or no? Tuple by tuple, tuple by tuple, individually, independently, individually, independently, individually, independently. So tell me, when you apply this on this tuple, then what is max age? See, when I apply this on this tuple, then what is max age? Let me know. When I apply this query, then what is max age? Max age of this tuple. See, for this tuple, age is 20, and for this tuple, max age is also 20. Yes or no? For this tuple, max age is also 20. Age is 20, max age is 20. So this tuple will be selected. This tuple will be selected, right? Okay, very simple. Similarly, for this age, for this age also the same thing. This will be selected, because for this tuple, max age is 21. For this tuple, max age is 22. For this tuple, max age is 23. All the tuples will be selected. So remember, this query will give you what? This query will give you all sellers' names. Is this clear? You will get all sellers' names. Please tell me, understood or not? Let me know. Because remember, this is tuple selection condition. This tuple selection condition will apply to one tuple at a time, individually, independently. Okay. So when you apply this condition on this tuple, then max age is 20 for this tuple. This condition will apply on this tuple. So max age is 20 for this tuple. Okay. Is this clear? Let me know. So actually, where is the problem in this query? Why problem is happening? Let me know. See, when you write this query, I want age of oldest seller. I want age of oldest seller. Right? Okay, oldest sellers. Now this is what I want. Now when I write this query, that okay, that sellers table, from sellers table, where age is equal to max age. Okay, select name of oldest seller. I want name of oldest seller. Select as name. So where is the problem happening? See, the problem happening is, let me tell you, the problem is this. Actually, we want max age of the entire table, but we are getting tuple wise max age. Yes or no? See, this is giving you tuple wise max age. Right? Yes or no? This is giving you tuple wise max age. But actually, we want, this is not giving us max age of entire table. Yes or no? Not, this is not giving us max age of entire table. Yes or no? Do you agree with me? We want max age of entire table here. Yes or no? I want max age of entire table here. But this is giving me, tuple wise max age. Okay, this is not giving me max age of the entire table. So what is the solution then? Tell me, what is the solution? Tell me the solution. Let me know the solution. What is the solution? Please give me some solution. The solution is, basically you find here. Remember, our purpose is to find max age of the entire table. So you do something, and you put a query, you put a sub query to find max age of entire table. Max age of entire table. Yes or no? Just put a subquery to find max age of entire table. So you remove this. I want max age of the entire table. Then what I can do? Very simple. From the entire table, from the sellers table, okay, I will select, I will find the max age. From the seller table, let me find the max age. Let me find max of age. Yes or no? Let me find max of age. From the seller table, let me find max of age. That's it. Now I have max age of the entire table. Yes or no? Now I have max age of the entire table. Is this clear? Max age of the entire table I have. But one more question I want to ask. What is that? One more question. What is that? See, one more question is this, that age should be equal to a value. Is this a value or is this a table? Is this a value or is this a table? Just tell me, is this a value or is this a table? This is not a value. This is a table. Yes or no? This is a table, right? Do you agree that this is a table? This is something like this. Max age. Let's assume max age is 50. So this is a table. This is not a value. This is a table. So can I do this? That age is equal to table. Can I do this? Age is equal to table, because this is a table, right? This is a query. This is SQL query. This is subquery. This will give you a table. This will give you this type of table. Max age 50. So can I do this? Age is equal to table. The answer is this is allowed because there is a guarantee that you will have one tuple. See, SQL knows, remember, SQL DBMS, your DBMS knows that you are using aggregate function here. When you use aggregate function here, is there a guarantee of one tuple? DBMS knows that you are using aggregate function here inside. You are using aggregate function. So there is a guarantee of single tuple. There is a guarantee of single tuple. So DBMS is thinking, because there is a guarantee of single tuple you are getting. Okay, no problem. Let me convert this table into value. So please understand, in the normal scenario, this query will be invalid. Okay, because age is equal to table. Okay, yes or no? You are putting table here, age is equal to table. So in the normal scenario, this will be invalid. But because I am using this aggregate function here, DBMS knows that you are putting this aggregate function. So there is a guarantee of getting a single tuple. Okay, so no problem. This SQL will convert this table into value. Okay, SQL internally converts this into value. Is this clear? So SQL will internally convert this into a value. Okay, because there is a guarantee of getting a single tuple. If you don't have aggregate function, if I directly put something else, then this is illegal. Then this is invalid. Because there is aggregate function, so DBMS knows there is a unique tuple, there is a single tuple. So DBMS will allow, SQL will allow this. So SQL will internally convert this into a value. Is this clear? Please tell me, let me know. Let me know. So I hope this point is clear. When we use aggregate function inside this subquery, then SQL will internally, it will convert into value if you write like this, age is equal to this. Okay, so this is allowed. Okay, so remember this is a fine. This solution is a perfectly fine. Let me know, is this point clear? Let me know. No, single tuple and single attribute. Single attribute, single tuple. Okay, single attribute, single tuple. See, here single aggregate function, single tuple. There is a guarantee of single aggregate function, single tuple. Okay, this will give you the guarantee. This will give you the guarantee of single tuple comma column. Okay. A student is asking, can we put two attribute function, two aggregate function? A student is asking, can we put two aggregate function? Tell me, what do you think? Just use your common sense. It's not complicated. Tell me, if I use two aggregate function here, if I use two aggregate function here, then this will be illegal. Then this will be invalid. Okay, here you have single tuple, single column. So this is a valid. SQL will internally convert into value. Okay, let's move on. So we have seen this, as I told you, that SQL will internally convert into SQL convert such a relation to filled value. Okay, so remember, this is also correct. You can also write like this. This is also correct. Both are correct. Both the queries are correct. Okay, you can write age is equal to this, or you can write this equal to age. Means it's like this, A equal to B, or you can write B equal to A. Both are fine. Okay, so very simple. Now let's move on. If I want to count number of sellers, then this is the query. Very simple. From seller, select count star. This count star will give me number of tuples. Okay, very simple. So count the number of sellers. Like this, you can count the number of sellers. Just do count star. This will give you number of tuples. Okay. So aggregate function we have already seen. I told you count star counts the number of rows. Okay, count star will count the number of rows. That's it. Okay. So SQL summary, this we will continue in the next session. I hope you loved this session. Please tell me in the comments. Please let me know. Did you like this session? We have covered every important point, every concept, every tricky question. Okay, in any concept, what tricky questions are possible in the gate exam, where they can basically they can try to, you know, what is the word? So they can basically where you can get negative marks. Okay, where you can make mistake. Okay, so where they can trap you. Yes, trap. Okay, so everything we have discussed. Okay, so please tell me, did you like this session? And we will continue this SQL complete summary in the next session. Okay, so to be continued. Okay, thank you everyone. One very important note I want to tell you, that SQL queries that we execute, all these SQL queries, these are retrieval queries. Means you have your database which is stored in the hard drive, right? Yes or no? See, this is your hard drive. In the hard drive, you have your tables, your database. This is your database. Now, this is your hard drive. Okay, now remember, now when you are executing any SQL query, okay, this SQL retrieval query, okay, so SFW, okay, when you execute this query, then remember, this database will not change. This data will not change. Okay, these tables will come in the main memory. These tables will come in the main memory, and here everything will happen. Your original data will not change. Remember, SQL retrieval queries, all these queries that we see, select from where, okay, all these queries, all these SQL retrieval queries, they will not change your original database, your stored database. Is this clear? They will not change your stored database. Basically, these tables will come in the main memory, and then the output will display to you. Okay, so is this clear? So remember, when I say that union, for example, okay, you have query here and you have union here, then remember I told you that union will ignore the duplicates in the input table. Okay, it's not like that union will go and remove the duplicates from the original database. From the stored database, the union will not remove the duplicates from the stored database. Union will ignore the duplicates in the input tables in the main memory. Okay, is this clear? So when you apply, for example, this is your table R, this is your table S. So from the stored database, table R, S will go in the main memory. In the main memory. Okay, and there, this union will ignore the duplicates of R, S. Is this clear? So all the SQL retrieval queries that we study, SFW, select from where, all these SQL retrieval queries that we study, they do not change the stored database. They never change the stored database. Okay. Okay. Thank you, everyone. Please put a comment.